and welcome to Qubes OS Summit 2024. It's my pleasure to welcome you in this wonderful event. I'm very happy that there are so many of us, despite there are still free seats. I think we should have like slightly bigger overbooking, but anyway, Marek, do you want to say something?
No. Hello, welcome.
Okay, let's go with welcome slides.
Yeah.
So we have 3-day events. We're starting today, Friday, 20th September, and finishing on Sunday. Together with Invisible Things Lab, 3MDEP is organizer of this event. And we, of course, couldn't do this without our wonderful sponsors. So let's start with Platinum sponsors. Freedom of Press Foundation is our generous contributor. They even decided that our biggest package is too small, so they added something more. So we should thank them very. We agree on the commitment of Freedom of Press Foundation to defend press freedom and digital privacy. And of course, we would like to support them in building secure communication tools. This supports with the mission of Qubes OS Summit to have this coordination between developers and the users of Qubes OS. So yeah, so thank you very much for sponsoring us, and huge applause for Freedom of Press Foundation. Our second Platinum sponsor is Malvat. We know Malvat very well. This is very well respected privacy, very transparent and privacy company. They helping us with their VPN, but they also have a browser, which some of you might be using. So what is more important, you can support those who support us. You can, of course, use their service, use their web browser, and I think that's the best way to thank Malvat for sponsoring 3MDEP. So huge applause for them. So we also have two silver sponsors, Nova Custom and NitroKey. Nova Custom deliver Qubes OS certified hardware, which maximize transparency and trustworthiness. They, of course, also use open source firmware like Dasharo. So we are very thankful for sponsoring the event. And there's also NitroKey. They also selling hardware with Dasharo, but also with heads, which is very important. But I guess like NitroKey is very popular from selling USB FIDO tokens. And they also contributed as a silver sponsor. So huge applause for Nova Custom and NitroKey. And there is small contribution from Starapps Ltd. Starapps is a company which use Qubes OS, which use a lot of open source, and they decide to contribute something through Open Collective. So applause for Starapps. Okay, little bit of history. I always have this slide with logos, but of course, at some point, there will be so many logos that I will not fit on this slide. This is 6th event. I'm very happy that it started in 2019 as a very small meeting and kind of evolved to this conference, and I hope to grow it even more. Of course, with new hardware vendors, with new community members. And yeah, so maybe let's talk a little bit what we were able to accomplish over last year. So first of all, we increased the number of Qubes OS hardware certified devices from 6 to 9. It's a 50% growth, but last year we reported 100% growth from 3 to 6. Yeah, so those numbers are still not very impressive, but we're going in correct direction. If we can keep the 50% growth, that would be very good. Of course, like I guess it have to be a little bit more because units of hardware are.
Yeah, or maybe 3 more models each year.
Oh,
that's also good.
Yes. But the problem is, of course, some hardware getting older and it's no longer available. Like those ThinkPads. They kind of like you can take some refurbished one, but it's slower number on the market. Qubes HCL statistics also not growing so fast. Last year we reported like 138, something like that, growth of the Qubes HCL. This time just 61. But it's up to you to promote Qubes and to tell people to just run the report and send the report to the community so people know what other hardware than the certified one runs Qubes well. Or if it's not well, then at least we know what's the problem. So I guess a great achievement is Qubes OS release 4.2 and subsequent smaller points of releases, but I guess Marek will have that during his presentation in detail, so I will not go too much in that. There are several UX improvements and new graphical tools, including new Qubes Global Config, which is very nice. There is FWPD integration, so you can already update your firmware from Qubes. Of course, this was contributed quite some time ago, but there were also some problems, and it took time to introduce that into Qubes. My selection of community projects is like my personal opinion of Ben Grande QSAL, which is kind of aggregation of salt stack configs also from Unman. So this is great project in my opinion because it speed up the new instance of Qubes setting up according to what you did on your previous instance. So I really recommend learning Salt and using it for configuring your devices, and this project should help you with that.
Yeah, but this also shows that community around Qubes is growing. We have more and more community projects that are built around Qubes, so it's great.
Yeah. Some improvements on event organization. I think like this time it was way less chaos. We had the location for some time booked. The CFP process was great because we even rejected quite some topics.
A lot of submissions.
Yes, a lot of submissions. Some unfortunately some cancellation last minute like yesterday, but we will let you know about that. And we replaced that with some design session. So that's one thing. I guess other improvements are much better communication, and I think like the video setup here is also well managed by our team. So maybe round of applause for our team for putting these cables together. What's coming? Like I'm repeating that again, but those are important things. And we should really work together to make it happen. So UEFI Secure Boot integration. I have my own presentation where I will tell why it is important, despite there is a lot of FUD around that. Yes, Trench Boot, Anti-evil-maid, I guess it's going very well. Like, can you say 1-2 sentences about Trench Boot support? There will be presentation today, but I guess even with some nice surprises. So stay.
Yeah, my slides about that also say.
Okay, let's not spoil it too much here. Certified hardware with Intel boot guard for those who want it. Even the version of fusing your own keys. This is something we're working on. It's not that easy because there is a huge risk of damaging your hardware in irreversible way. So this have to be done in a careful manner. UEFI capsule update. This is something very important that is natural next step after FWPD integration, because now we have to go for certified, let's say certified Nova Custom laptop. We have to go to BIOS and run this firmware update mode, which temporarily disables the logs, reboot and do the update and gets back and enable the log. So this is kind of workaround. Of course, this is very hard to interrupt this process and like remotely probably not possible. But anyway, this is not perfect. The better way is UEFI capsule update in a way that you're essentially feeding the capsule, rebooting, and core boot, fetching this itself and do the update. So that's very good feature to have. And it's compliant with a lot of FWPD plugins. SMI transfer monitor, this is other thing which is important to protect us against potentially malicious SMI interrupts.
Yeah, but this, I guess, will be covered in the separate presentation.
Yes, I'm not going into details with that. So in terms of growth of the users, I guess the growth is steady. I really don't like that this is different colors because the previous one was, 22. Because if this would be the same color, we will see better this animation. But anyway, it looks like it's, I would say 10%, like solid 10% growth. So congratulations to Qubes OS team for that, and I guess let's keep that tempo.
You can see a small number of 4.3 already.
Yeah, that's me. No, I guess that's the developers of Qubes OS and probably associated like community members. Okay, in terms of like achievement from last year in the low level stuff, improvements in UEFI secure boot, many in Dasharo. So that was thanks to Marta. Of course, this is like already quite old, but anyway, we didn't share that yet. In case of vision for the next years, from perspective of 3M Dep and Qubes OS certified hardware and how to support it, we have very old OptiPlex 7010 finally coming up, but it will include Anti-evil-maid. So and it's very cheap hardware. Like it's like, I don't know, 150 euro or something. Not much memory, but anyway, this could be interesting for some people. There's Odroid H4. The question is if this like 48 gigs of memory is enough, but that's the choice you probably will have. And new Nova Custom laptops coming. I guess that will follow up also with new Nitro Key hardware. And who knows, maybe there is something behind the scenes going on. I don't know, Marek knows better. Qubes Anti-evil-maid should be finalized. We have some plans for supporting not only CBIOS but also UEFI. This is already founded. The plan is known. It's just a matter of time to develop that and upstream.
A lot of that.
So I don't know if we will share that next year, but we hope so. There is also AMD support. Of course, like everyone would like to see more AMD hardware because AMD is right now the great company. Yeah, but it has its own issues. But they right now, as it was said at Linux Plumbers conference, should release the documentation which allow anti-evil-maid development and upstreaming. Yeah. UEFI Secure Boot, I already said. Qubes Security Report, this is something that we will have design session about. Yeah, and more probably on in Marek's talks. Okay, so today we have a first day of conference, which I will tell you about the agenda in a second. After that, we have a after party in Suit Block, as always. And tomorrow is another conference day, and on Sunday we have a hackathon, which is in the same hours from 10 a.m. to 6 p.m.
Yeah, and on hackathon, if you have some ideas during the presentation on something, you can plan what you'd like to do during hackathon. So it's we have some time where we are together. We can do some funny stuff.
Yeah, I already have some ideas. I definitely have to learn how to use Qubes Builder version 2. It's like something very hard for me. Okay, so we are right now at the first presentation. The next presentation is Qubes OS development status by Marek. After that, we will have Qubes OS graphical user interface changes and future perspective by Marta. Like we always welcome this talk because it's like a little bit different perspective than most of us have. Enhancing OS awareness of hardware security capabilities. This is design session, which will contain materials that I already discussed on Linux Plumber conference, and would like to bring this to your attention. We will see where this will go. Passwordless encrypted Qubes OS 15 after 12. This is by Nestir. I don't know how to spell that, I'm sorry. From Nitro Key. Then we have very long lunch break, as it was requested last time, because 1 hour was not enough. So it's like 1.5 hours this time. Perfect. Yeah, I know that this is the best part of the agenda. Then after the lunch we have how to architect your Qubes OS with Salt Stack by Ben. It's like I'm very happy with this talk, and I will tell you quickly why. Because last time I gave Salt Stack talk, and it was noob talk. It was like lame talk because I was so weak in this Salt Stack, and Ben said like, you know, this you can do better, that you can do better. And I said like, Ben, can you have a talk next time? And he said, I don't know. Like, please. And I said, okay. And yes, we have this talk. And this is like when my talk was in kindergarten. This is like a high school or college stuff. Yeah. So yeah, FlashKeeper by Thierry. This is also very interesting talk. What we can do with the security of the platforms and how to go in the direction of stateless laptop. Then Anti-evil-maid from Michał from 3M Dev. After that, we will have rolling. I guess this is something that is. I guess
this one is cancelled.
This is cancelled, and I didn't update the slides. Yeah, this one is cancelled, and did we replace?
Yeah, I think we moved the update on Qubes OS Air a bit earlier, and we have some time for
for discussion.
Discussion.
Okay, so that's the plan. I'm sorry, I just forget to update this slide. And then we just closing, and 7:30 p.m. we meet at Sud Block, and I will. So the details of the agenda are behind these links. You can just simply go to cfp3mdev.com and you will find Qubes OS, or to vpub-aro.com, and there is embedded version of the agenda there. And the after party will be in this place, just Sud Block. I don't know how far it is from here. I don't know.
Last year, some of us walked there, so it's
how?
not.
Maybe like 30-minute walk.
30 minutes walk.
10-minute subway.
Something like that,
Okay. So that's it, and a little bit about the rules and other stuff. So please respect code of contact. Please respect each other's opinion. This is like a technical event. We don't want to go too much into other stuff like politics or this kind of stuff. Please follow the safety and healthy protocols. Talks are streamed and recorded unless you reported to us that you don't want that. Drinks and sweets are for free. There is the case with the toilet. There is a badge for the toilet. The toilet is closed. You need this badge. So please take the badge. It will be near the doors.
And then return it.
Yeah. Please return it.
Or you can go with the lift to the other.
Yeah, the toilet on -1 level is open, but you need to go to the using the lift, not stairs, because stairs are closed.
Okay.
Yeah.
Well, that's good to know. The communication channel is on Matrix. It's Qubes Summit. If you want to talk, that's a great way to connect with other people, also those who are remotely.
How do you ask questions to presentation if you are online?
Yeah, that's a very important thing. We have a mic, and we would like to ask you, if you want to ask questions, please go to the mic and ask to the mic, because people then complaining they don't hear the question. The speaker not always repeating the question.
Yeah, so at the end of presentation, just queue up to the mic there, or online. Do we have?
I guess we will look online for the questions at the stream.
Yes.
And I guess if there will be any questions online, we will try to pick some. Of course, I don't think we can answer everything, because there is some limit to.
Yeah, we have 5 or 10 minutes for questions reserved, something like that. So,
Yes, unless someone finished earlier. In case of any issues, violation of code of conduct or this kind of stuff, please contact people from 3M Dev or from best probably Marek or me. So we will deal with that. In case of merchandise, there are free and paid one. The Qubes OS Summit official T-shirt is €25, and it's available, I guess, back there. There are also
here.
Here.
Yeah.
There are also some stickers, some other stuff lying there. I guess you have also some stuff.
Yeah, we have also T-shirts from some from the last year, and for the other designs of Qubes OS T-shirts. There is also some price for them. I don't remember, but they are on the back.
Yeah. So if you want to get some stuff, support us in that way. Please.
There are very few, but we still have Qubes OS mugs.
Okay.
I have 10 of them or 5. So
it's a unique series.
yeah.
Please consider. Okay, I guess that's it. How we look into with time.
5 minutes left.
5 minutes left. Yeah. So, any questions? Maybe there are.
Just a quick question. Because there are some empty seats, is it for folks who wanted to come in person but were not able to come? Is there Yeah, is there a moment when we decide that we can allow people or invite people who wanted to join? Is that not?
That's a
yeah.
good question.
That's a very good question. Yeah, I assume some people even 10 a.m. is for some is very early, so.
So there is also a possibility that because we didn't have division of per days, yeah. So people who probably, for example, will come tomorrow, they just like booked the ticket, and we have like free seat right now.
Yeah, but I guess we can, if there are some people who are in Berlin and want to come, they can try, and if the room will be free, then if there will be some free space, then
Yeah. So right
Yeah.
now, for those who watching us on YouTube, like we can say there are quite a lot of seats. Like I would say like 50% seats are free. I guess we can assume that 20% will be free no matter what. Yeah. So I guess like that's our. We have to learn how to do this, like, and like what kind of percentage of overbooking is allowed for us. Yeah.
Learn from airlines.
Always.
Yeah.
I don't know what.
I don't think that's a good example, but yeah.
Like we're looking for candidates who wants to resign from his seat. That's the problem they sometimes face.
I have a question from the internet. That is, where should people ask questions from the internet if they will?
On the this is the question I asked here. So either on YouTube in comments or in the Matrix channel, I guess. Do you monitor Matrix? Matrix. Yeah.
So please go to the Matrix channel and ask the questions on Matrix channel.
Qubes Mini Summit channel, right?
Qubes Summit.
Qubes-Summit.
Qubes Summit on matrix.org.
Yes.
How about YouTube stream chat?
Yeah, I guess like we will not follow the YouTube
No.
stream chat.
No,
Yeah.
no comments on YouTube. Okay.
Yeah, that was. We didn't thought about that. I'm sorry. Okay. Any other questions? Okay, I think we can take a short break before next presentation for the setup. Okay, thank you very much.
Welcome again. And excuse me.
Silence.
Could we start?
Hello.
People. Yeah. I would okay. Welcome again, and yeah, I will give some update on what is happening in Qubes, what we are working on, and what's in the near future. First of all, I will give some updates about Qubes 4.2, which is a current stable release, and then plans for the Qubes 4.3, what is happening. 4.2, we just released the third point released this week on Tuesday or Wednesday, like a moment ago. With this release, there are not many changes, but there are some updates, especially to the kernel version, necessary for the Nova Custom laptop, that is the new certified hardware. There is some work in progress on Fedora 41 template. Fedora 41 is currently in beta, if I remember correctly. So there is no official release, so there is also no official template yet. But we are on a good track to have the official template very shortly after official Fedora release. We'll see. And also many of the improvements, many of the fixes that are coming into Qubes 4.3 are being backported also to 4.2. This includes some of the fixes to the user interface, some simplification, some better messaging. For example, one of the things is real-time information in the updater, so you can better follow what is going on, and is it downloading updates, or is it already installing, and stuff like this. Anything that is not like strictly compatible is not going to be backported, but some of the improvements we try to give them to users quickly. Yeah. So for Qubes 4.3, we have several points here. The main topic, I would say, is new device API, device workflow. A large part of this assigning devices is being rewritten, or I should say it was already rewritten. This allows better managing of all kind of devices. Is it USB device, block device, PCI device, some audio, video input, all kind of devices. We have more info. I will have separate slide on that. There are some QRexec improvements. There is something about Qubes Air also in a moment. So there are a lot of things, and as usual, update the Zen version and DOM0 to a more recent distribution. So for these devices, there is a new concept of required devices that you need for the VM to work. Previously it worked quite well for PCI devices, but not any other kind of devices. Like if you had an external disk you use in a Qube, that was quite tricky to get it right. So we have this improved. We have more metadata about devices, so it's not just some device ID which was not even stable. So if you have two USB sticks connected, the ID was different depending on the order in which they were connected, so it was quite inconvenient to work with. So now we have two concepts. One is the device port ID, which is where the device was connected to which place, and the other is self-identity, which is more like what this device claims to be. So, yeah, and also we are experimenting with some auto-attaching of devices. This is something that will not happen automatically, but you can enable, like, if I plug this particular device to this particular port, it should automatically connect to some specific cube or something. We are experimenting with that. We'll see. Yeah, so more details on that. We will have separate presentation about. Piotrek is main developer of this feature, so he will tell more about this. QRexec policy using UID. This is, I would say, small, technically small change, but I think quite important, because when you create some policy for QRexec that this cube can, I don't know, send file to other cube or connect to something. Normally those policies are based on name, and you can create a cube with a given name, then remove it, and then create again with the same name, and those policies would still apply, which may be what you wanted, but maybe not. Especially in case of disposable cubes, which are this and some number. This number is, we have some code that checks if it wasn't recently used, like for, I don't remember exactly, a week or something, but it's not guaranteed to be unique forever. So if you had some rules for some disposable cube, if a new cube would exit with the same name, the old rules would still apply. We solve this with UID, which is guaranteed to be unique, like forever. This and the other addition, where we can put extra, we have some extra directory for policy rules, which gets automatically removed after the system restart. So you can have some policy rules that works only until you restart your system. So you don't have to, like, remember to clean up something. Like next reboot and all stuff is gone. Yeah. So this is something that is already. No, it's not merged yet. I don't remember, but it's already implemented. And kind of related, we have some update on Qubes Air. This is a concept that Joanna announced in 2018. It's 6 years? 6 years ago, so quite some time. Not much was happening in this topic for a long time. There was proof of concept of some part of that in a hackathon on Qubes Summit 2 years ago, I think. But yeah, not much was happening. So we are coming back to this idea, and we have some progress to share. We selected subset of that design and decided, oh, okay, let's try to implement it. We will have some separate presentation about more details, but what we selected is a specific use case that you have two Qubes machines and you want to do QRexec calls between them. For example, copy file from one cube on one Qubes OS host to another cube on another Qubes OS host, which currently, without something like this, is not very convenient, I would say. You could use, I don't know, USB sticks or some cloud service like upload to the internet and download on the other host. It's not convenient at all. So we are going to improve this workflow, and there will be a separate presentation how this will work and how this can be extended to other use cases. Yeah. As usual, there are a lot of UX improvements. Marta will give more update in the next presentation about that. So there's template manager. This is very interesting thing, because we've got this the current template manager. It's one of the Google Summer of Code project. It was quite successful, I would say, but the graphical interface for that tool is not very intuitive to use. So this is going to improve in Qubes 4.3. And there are also several other smaller stuff. Like I said, there will be a separate presentation with more details. This is a thing about Qubes Windows tools that a lot of people are asking about. So there was we had Qubes Windows tools before. They used Zen PV drivers that were built by Zen project, and they were signed by Microsoft. It worked quite well. But then there was some issue with apparently with those drivers, and they discovered that the build host that they used for building those tools was not very trustworthy, and they decided to recommend to not use those binaries by anybody. So that could be easily solved by simply building the drivers ourselves and asking Microsoft to sign them. If not, one tiny detail. In the meantime, Microsoft changed the rules for signing drivers, so the old approach was not possible anymore. And the new requires quite some work. We are working on that, but this will need some time. So, yeah, there are some updates on that. We decided, okay, so let's build our the drivers ourselves and try to go through that process. But until then, we will have we'll go back to the stage where you need to accept that drivers are signed by some third party. It's quite scary warning, but yeah, what we can do. But also at the same time, we are doing a lot of updates to Qubes tools, especially GUI agent for new Windows. So you will have some individual windows from individual applications, as you can do on Linux, also in Windows 10 or newer. Yeah, there are some more updates like GUI domain support, which wasn't the case previously because old Windows tools used old API for this GUI protocol, which didn't support GUI domain. So there are more changes to the improvements to user visible features, but also there are some for developers. Especially this is using a new Qubes builder, and new Qubes builder has a concept of executor. So what actually is used for building? You can use a disposable cube, you can use Docker image, but we discovered that it's not that hard to also have a disposable Windows cubes for building Windows stuff. Previous tools, Windows tools, were built on Linux using cross-compiling to Windows, which surprisingly worked for the small part we used, but it doesn't really, it's not very reliable, especially if we build all the PV drivers now. So we need to build Windows tools on Windows now, but we can do that with new Qubes Builder. So yeah, so when it's coming. Currently, the actual PV, the Windows tools and PV drivers, they are quite ready, I would say. We are, or Omeg specifically, is working on finalizing the integration and installer. So it's because also there's we jumped with PV drivers version like 2 or 3 years ahead, because we used very old version before. So there are quite some changes, and yeah, the installer needs a lot of updates also. I'm not sure if it will be possible to update, like if you have old Windows installation with old Windows tools. I'm not sure if it will be possible to update to the new Windows tools version. This is getting install the old version and install the new version, or in some cases reinstall the Windows. Unfortunately, we will try to do something about that, but it's we don't promise anything here. Next thing is Trench Boot based on Anti-evil-maid. We will have some separate presentation on that, but generally the plan is that because the current Anti-evil-maid is very old and not really maintained, and it's using some components that are not maintained anymore. So we are together with 3MDev working to get this supported again on new hardware. Especially AMD support is coming, for, hopefully, and also UEFI systems. This is a huge topic because there are a lot of differences between, especially in the boot process relevant to Anti-evil-maid, between legacy BIOS and UEFI. And there are a lot of challenges, but we hope to get Anti-evil-maid compatible with UEFI systems finally. Yeah. So there are 2 main parts are in one is in bootloader in Grub, and the other is in Zen. The Grub part is completed. It's already included. In our version of Grub. The Zen patches are in very final stages of review. I will do that. Simon, how far are we?
Yeah, as you said, final stage.
Final stage. Okay. Okay, so there will be a separate presentation about Anti-evil-maid and Trench Boot. Okay. Another thing, faster disposable cube startup. If you are using disposable cubes a lot, the few seconds you need to wait for it to start is annoying sometimes. So we have a solution. This is the plan that is that was written in some of the GitHub issues for a long time. This may be one of the oldest issues, but the plan is generally to start those disposable cubes early and keep them keep some pre-started disposable cube around. It may be simply running without any application, or be a cube that is started but is paused. And when you need a new disposable cube, we can take this one this pre-started one, and just run the application you requested. We had something similar in earlier Qubes version, I think Qubes 2.0 or something like that. We started disposable cube and then dumped its content, suspended it to disk. It worked, but it was not very reliable, and it was not compatible with having multiple CPUs in a VM. So it was those disposable cubes always had only one vCPU. There was some limitation in the RAM size. So yeah, that was unreliable. So we at some point went back to like starting from scratch a VM, but we have we'll try to get a faster disposable startup again. This time with proper like normal startup, but do it early. Just some side note, there is a feature in Zen that you can start a VM and then clone a running VM. So basically like VM forking, the feature is called. It sounds like it would be nice idea for this feature, but unfortunately this feature is not designed for like long-running VMs. It's only a feature for some fuzzing, and a VM that is cloned from another running VM cannot really survive that long. There are some missing parts, like I think it loses access to all the devices, for example, which is not great. Yeah, so if somebody finds, oh, there's this feature that would be perfect, yeah, it looked like it would be perfect, but actually it's not. And also there would be a risk of sharing too much data. For example, the pre-started disposable cube had some random seeds or some temporary keys generated or something. If you fork that VM, like clone the running VM, those would not be secret anymore. Like they would be shared between different instances. So that would be bad. So unfortunately, no. Yeah. The next topic I have is GPU acceleration. This is a very complex topic because GPU are very complex devices, and they focus mostly on performance of the rendering stuff or computing stuff. There is vendors here have a lot of incentive in making it faster, but not that much incentive in making it secure, or in some cases easy to virtualize. In some cases, they even have the incentive to break virtualization on some low-end devices, NVIDIA. So yeah, virtualizing the GPU is very tricky topic. But we've done, I should say, DEMI specifically, extensive research of different solutions that are used for this. And we have some ideas how to do that that would be kind of acceptable for Qubes OS threat model. The initial version, yeah, so we try to reuse some projects that are doing something similar and try to pick the best possible solution security-wise that is still going to be maintainable. Because there are some solutions that are, for example, very specific to a very specific GPU model, and others are not supported, and you would need something completely different for other GPUs. So that's not going to work. But we try, we've looked like we could use Virt.io GPU as a transport layer for sharing graphical buffers with GPU and all the data to avoid copying in from RAM to GPU and back and forth. So this is one example, or native context that for isolation that provides some level of protection and is actually going to be supported like security boundary. One of the criteria we use for selecting those technologies is what other projects are using and what other projects are supporting, especially in the context of security support, because we don't want to maintain our own GPU acceleration framework. This is a huge topic that like huge companies are working specifically on this. We are a very small team, so that's not realistic. So we took a look what is used in Chrome OS and also Chrome browser, in some other projects that are providing GPU access to untrusted context, untrusted code, and this is the solution we currently decided on. There are a lot of missing parts. Some of them are in development by other projects, some of them are in development by us. For example, the proxy for Wayland protocol, this is also that is something coming as a side effect. Currently, we have our custom GUI protocol, which is translated on both sides to and from X11, and it works. But adding GPU acceleration to that would be rewriting a lot of code that is already written for Wayland into our custom GUI protocol. And contrary to X11, the Wayland implementation actually at least tries to isolate stuff. It's not like in X11 every application can do anything. So this is something we are trying to adapt. We'll see. This plan is not set in stone. It can still change. We are exploring with like playing with the ideas and preparing some proof of concept and trying whether all this works together. We'll see. Some parts of that may come to Qubes 4.3, most likely not all of that. As I said, that's a lot of work, and we have also some dependencies of third-party projects, so we'll see. And if you would like to learn more about technical details, there was a presentation at Zen Summit this year from Demi, where she went quite deep into the details. And finally, we have some community. A lot of community projects are quite active. So, for example, tool for distribution upgrades for a template. So when the new Fedora version is available, you will be able to upgrade it to the new version, hopefully automatically. We'll see. Or maybe better backups using Wing Backup with support for incremental backups and much faster backups than the current version. And there is a lot of small contributions. It looks like somebody, a few people had quite some time during summer period, and there was a time where I've got more pull requests from external contributors than from our team. It was quite interesting, and looked at statistic. Ali was specifically active and still is quite active. So, yeah. I'm very grateful. It's a lot of good work there, and a lot of small annoying issues that are each of them is very easy to fix, but there are a lot of them and nobody had time for select and work on that. So yeah, very good work. Yeah, so that's the main points for the updates. There are obviously a lot of smaller things coming, but yeah, main topics are here. Are there any questions?
No questions on chat.
Okay.
regarding trench boot.
Uh-huh.
What you can say that already works from your perspective?
That's a very good question. I've tried the older version of the patches on Qubes 4.2 and trench boot, like whole boot process on legacy boot worked, and all the PCRs were extended, etc. So the legacy boot workflow worked. I've heard some issues with some later change. There were we'll see. And there is one more thing, problem, I'm not sure, that you are probably not aware yet. So the patches were prepared on Zen 4.17. We are updating to 4.19. So there will need to be a rebase. I hope it will not be that complex. And the same applies also to Grab, actually. We are keeping old version of Grab right now.
2.06.
Next
Yes.
question.
Yeah. Yeah, so there will be some work, but yeah. Some of the legacy boot work
Next
worked
question,
already.
please.
Just wondering if you had ideas about Windows templates.
Yes, there are, technically it should work even right now. In practice, there are some problems with what Windows assume should survive the reboot and what should be private or not. For example, if you connect your Windows VM to Active Directory, it generates some private key. And currently, if you use templates, this private key would be shared with different app VMs, and it's bad because it should be private, really. So there may be some security implications if you use Windows templates, but technically, if you don't have different trust levels between different app VMs based on the same Windows template, it should work with the current Qubes tools.
Last question, please.
Yeah, also short, we heard in the introduction that there are like these lot of different salt configurations around, and I wonder if there is like any plan or idea to implement that in more like the GUI to like kind of choose, for example, during install, I want not the basic setup we now have, but I actually want the journalist setup or...
Yes, so this is something we have discussed before. There is, Marta also prepared some time ago a proof of concept of the interface for that. Yeah, you did that.
Okay. Trust you.
I've seen it. But this is something that like follow of the current development and was kind of abandoned due to like higher priority work. So yeah, we would like to come to this topic again at some point, but we need somebody like to drive this discussion and design. Yeah. Thanks.
All right, welcome everybody. My name is Marmarta. I'm going to be talking about what is happening with Qubes graphical tools and graphical stack. Yeah. First, I wanted to answer a question that has been asked to me a couple of times. That is, why are you changing things? Things were, and it's terrible to have them changed. I like how they were. So, yes, I understand that change is something nobody likes, especially in terms of graphical tools. Every time something changes, people are like, no, no, it was better before. Turn it back. This is not a good way to go, because Qubes OS graphical tools were not exactly developed with a plan. It was more of like, maybe we can just put more drop-downs to a place and we'll fit everything in. And the problem is that what maybe was mostly working, like this is the very old 4.1 settings window, and it started at just like 4 or 5 options, but then it had more, stops being readable. Most features had graphical tools added as an afterthought, and the effect was very opaque for new users. I understand that it was very, well, you know, once you're used to something, you can manage it no matter how complex it is. But for new people, it was not that easy to use. And there are actually some reasons to have good UX that are security-based. It's not just me wanting to make things pretty, although I would like to make things pretty. And the main reason is that people are very lazy. We are very lazy. The easier good practices are, the more they will be actually used. Because unfortunately, you know, I may know that it's a good idea to open this and this link in this VM, but if I don't have a simple one-click method to do it, sometimes I will be like, oh, never mind, what can possibly go wrong? I'll just open it in the VM I am now. Humans are lazy. So I want to make UX for Qubes that is actually easy to use so that we do the good things more easily. Also, a lot of threats involve tricking the user. And if the interface we have is a random collection of widgets designed by different people that look completely different, it's very easy to be tricked. Because if you are seeing something that's very unfamiliar, well, that might just be another new brilliant widget, right? Definitely Qubes team made it because it looks random and different, so probably it's okay. Also, Qubes is pretty complicated. Well, if you know it very well, maybe not that complicated, but there are many layers and options. I want to make a lot of the options more visible, easier to use, because you cannot use all the fun things if you just don't know they exist. And we cannot just put everything in the documentation because not very many people read documentation. Some do, and I'm very grateful for everybody who does. But a lot of people don't. And when they do, we often read documentation in a very target-oriented manner. I want to do this one thing. I found a line that does this one thing. I'm not going to read anything else around it. Especially not things like warning, caution, option, something. This is boring. Let's not read it. So those are all the reasons why I'm trying to make a UX for Qubes that is good, consistent, and easy to use. So yeah, that's my general goals, and also to remove as many ways to shoot yourself in the foot as possible. Because Qubes is great, but it's also sometimes quite easy to change some setting and end up with problems that may or may not have happened to me more than once. So I want the GUI to offer useful options. Not every single option, but sensible options, useful ones. So now I'm going to talk a bit about some changes that we've made and some changes that are coming. A big change is a new widget for handling devices. It's a result of research, user research, talking with people, some debates, including last summit's design session. There are a lot of backend changes. I think Piotr is going to be talking about the backend changes. Well, and Marek mentioned them definitely, so I'm not going to go into details here. Now the changes are mostly, like on the front-end side, the changes are mostly cosmetic, but more will come in the future. So what we did, the old widget was, it was nice because it packed a lot of information in one spot. The problem is, it packed a lot of information in one spot, and the information was quite contextless. When I talk to users, especially new users, a lot of people were like, cool, I guess that this means I'm going to attach this device to a VM. What will happen if I click on another VM? Will it detach from the old one or not? What is going to happen? So I decided to move into the direction where the options are actually described. So you can see what the option is going to do. I decided to surface option detach and attach to new disposable cube, because this is something that a lot of people want to use. For example, when you plug in this USB stick you found in a parking lot. I added more descriptions. This is not a big change, but also the new devices widget will allow us to also add a lot of more fun stuff from the backend work, because now we have a space to add more options, and there is not just a flat list of VMs, and well, let's hope you guess what this does. Yeah, so, and now we have a dark mode that tries to actually be mostly visible, which is another improvement.
Yes.
It should be working. If you have any problems with the dark mode, please report them as issues. So yes, at this point we have now easily attaching to new disposable cubes. This is coming, not yet implemented. So display one storage device if you plug in a USB stick that has just one partition, and not like it happens now. Display everything and hope the user guesses which device you should actually connect. And a couple of options that are coming soon are things like easily attach to cubes to which you previously attached this particular device. An option to attach camera and microphone together, another thing that a lot of people asked for, and judging from our team calls would be quite useful when people connect and it's like, oh, sorry, forgot my microphone. So those things hopefully will come soon. And another thing that is going to come is improved attachment, that is, have actually meaningful options for auto attachment of devices. For example, ask to attach, whenever you plug in this particular device, ask to attach it to a certain cube, or automatically attach it to a cube, or require the device for a cube to start. The next change is the template manager, and Marek mentioned it a bit. So the problem with the template manager is what happens when you have somebody who is extremely brilliant, because the person who did the contribution was clearly a very good programmer, and is not very good at UX for the obvious reasons of not actually doing or being trained in that, so obviously they weren't very good at it. And the problem was that I've tried to test it on a couple of test subjects, and nobody I asked who didn't know this window before was able to guess where they should click to actually install an available template. Because the workflow was click on the available label and switch it to install. So this is an unusual approach. I understand why the contributor did that. That made sense for him. It was easy to make that in the available tools.
More drop-downs?
Yeah, exactly. When in doubt, just add more drop-downs. It will fix everything. So I decided to fix it a bit. It's not a complete rewrite, because the tool itself is great, but I want to, one, have it more similar to other Qubes applications for the consistency I mentioned before, and also to solve the problem of what? because a lot of users I talked about had this reaction when they first encountered the template manager. And the new template manager is not very different. Like, it still has all the templates listed, but this time I tried to add a bit more context, add a bit more explanations. I know a lot of people, especially people in this room, are not going to read those explanations. This is a lot of words. But when somebody opens it for the first time and does not know what's happening, some of those people will read it. Not all. A lot of people will just click on. That happens. It's okay. But there is an option to learn what the tool does. I also tried to provide a bit more, well, explained details about the template. Because, for example, in the old template manager, oh no, sorry. I was trying to lie. I'm not lying. In the old template manager, the options were the various information about template was described just by one word. Column name. Now, there are a bit more words, and the options are a bit more, the things you can do with a template are just a bit more explained. Install templates. You know what install does. I also added some, this is a development version, so not everywhere you can see it, but some templates here now have a marker that they are no longer supported. So, I mean, you still can install them. Why wouldn't you? We are, after all, Linux-based, so you can always, you need to have some way to shoot yourself in the foot if you really want it. But now at least users will know, okay, maybe installing this template is not the best idea. And also I tried to give a bit more warnings, because it was quite easy to do another foot gun with the old template manager, because template could have an option to upgrade, and it sounds like something you maybe should be doing. No, because upgrade, well, upgraded the template to a new version and erased everything you do. It was not update packages within the template, it was erase it and install it anew. So at least now, I'm going to warn the user that maybe you shouldn't. Of course, some people will still ignore the warning. There is a limit to what we can do, and I have also been the person who ignored the clear warning, so this is very human. But hopefully it's going to be a bit better. There is a lot of other minor improvements to Qubes menu, showing Qube settings in search, improving keyboard navigation. Something that is coming soon is an opt-in, show recently used applications, because this is something a lot of people wanted to have. And another big thing that I'm working on is making contributions to our GUI stack easier, because the thing is, Qubes is hard, and developing stuff for Qubes is hard, and testing stuff is hard. Yes, I do have my magical one-liner that allows me to move my package to DOM0 and test it there. This is not an easy thing to do. And people who are good at UX and good at developing GUIs are not very often in the same group as those who are good at Qubes. There is, I mean, I hope I am in the middle, but there are not very many people there. And I want to make it more realistic for people to contribute. So one thing that I've made is a simple set of mock Qubes objects that allows testing Qubes GUI applications within a cube or without a cube. You can just test it on whatever Linux you are using. You don't have to wrangle with stuff. This is, for example, Qube Manager running with this mock Qubes object. Also, it makes it easier to write tests. So I hope this will help more people be able to at least, start developing Qubes GUI tools. And another thing that is going to come is a style guide. And this is something that I'm working on, or this is worked on by the wonderful people from Ura Design, who are sitting right there, who are going to work on making a simple guide that will help us avoid the problems of old Qubes template manager. That is a simple document that people contributing will also be able to use to be like, oh, I need a button. How should that button look? No longer they will have to guess or add more drop downs as was the normal practice. And I hope this will allow us to make a consistent, useful, friendly GUI stack. All right, thank you. Any questions?
Maybe not exactly a question, but just maybe a small remark to guys who want the old GUI and those who like new GUI. Windows, that's such a wonderful thing. Like when they switched to Windows 11, let's say, they redesigned everything, but then you had on the margin of the window a small link to the old view. So you could possibly still reuse the old layouts and have your old known locations for the settings you wanted. But of course, this creates an overhead of managing two different sources for those.
We don't have enough
GUIs.
UX people for that.
Yeah, that is just a remark.
Yes,
such things exist in the world.
They do, but also they mostly happen when people are very fed up and force the company releasing a certain tool to allow them to go back to their old
Also not saying it is a right approach.
Yes, so this is not going to happen. For the obvious, manpower reasons. Even if I wanted to do that, we don't have manpower to maintain.
Yes, totally understandable. Thank you.
Hey, I just wanted to say thanks for redesigning the Qubes manager. Jesus Christ. I know personally a few people who have reinstalled thinking that it was just going to update their packages.
Yes,
I know a guy.
I am that person too.
Yeah. But I wanted to ask, what are some plans to sort of remove, or if you have any, dependency on mouse and improve keyboard movement?
So one part is, of course, always trying to fix the existing keyboard navigation for things like menu, manager, and so on. Whenever you have any opinions on that, please make an issue, because keyboard navigation is hard to get right. And another thing that I hope to be moving in the direction of, it's not going to happen in 4.3, but I hope to get rid of the bajillion tiny widgets that we have, which are very mouse dependent, and replace them with something that would be a one window that could be launched with a keyboard and also navigated with a keyboard. So this is my hope to go in that direction.
Yeah. Is it going to have Vim movement? Nah, I'm kidding.
Contributions welcome.
Yeah, basically not really a question, but just feedback. Really thanks for the redesign. I'm working at Nitrokey, and we get a lot of feedback basically on how Qubes is working. And I see much improvement there with 4.2. And yeah, also I remember like 2 years ago I did a talk where I talked about user stories, and actually seeing something of this developing there really was...
It was a great talk, and I took a lot of notes.
So yeah, really thanks for that. And actually I would say it improved a lot of things.
I'm very glad to hear that. Thank you.
Hi, any plans to make more things dark? Such
Yes.
as the terminals and the templates or something?
Yes, I hope to make things work with dark mode on everything. That is one of the things. That is also something that I'm trying to always do with every redesign, to actually make sure that dark mode does work and not maybe works.
Thanks so much. That was a great talk. I really liked your comment about consolidating actions so they have the same consistent approach. Do you have any other examples of that in other aspects of the GUI?
Like a very simple thing. I do want to make it so that, for example, the OK button is every time on the same spot, because right now it's basically random. If it ends up on the right, on the left, in the center, it happens somewhere, which really messes with muscle memory of users. I'd just like to note that this is probably the nicest situation in my life, where a lot of people had not really a question, but a comment, and all of those were very nice. Thank you.
So this is design session, and like I hope we can have like discussion to mic, so people remotely will also listen that. But I know it's also very hard to do the design session that way. So we already sorry everyone who's listening on YouTube. So it's about enhancing OS awareness of hardware security capabilities in Qubes OS, but it's not problem of Qubes OS only. So this is like a spoiler of the Michał Żygowski presentation, because this screenshot is a modified version of the Qubes OS report with some DRTM stuff. I know you cannot see that because it's too small, but believe me, there are additional features in this list than normally. And what's the case here? So lack of OS awareness about hardware security capabilities leads to the inability to evaluate and improve system security posture, and that's I guess like that statement which does not need any comment. The problem is that we don't have good mechanisms for that. It looks like everyone trying to implement that, and it's like a massive move in that direction. I was on a Linux Plumbers conference on Wednesday, and there was a lot of discussion about that. What's happened in other projects? So Genome got the device security settings. It's based on LVFS HSI. KDE Plasma going in the same direction, having firmware security page like just the output of the LVS HSI. Qubes OS security report based partially on the HCL, but last time we discussed that it would be based on HSI. At that point, I agree with that statement, and today I disagree with that statement after 12 months, because HSI got a lot of assumptions, and maybe I will talk about that later. And we also got a call with Free Software Foundation, respective Freedom lawyers, like lawyer plus someone else from the Free Software Foundation. We tried with Thierry to explain needs and potential of such checks, but it's very hard to get traction in this and very hard to bring other people on the same level of knowledge about the hardware security. So nice interfaces which with some success exist in Linux kernel are sysfs, sysdevices, system CPU vulnerabilities. I guess this was like because of Spectre meltdown and all this other speculative execution, there was a lot of cooperation in the ecosystem how to expose this information, and that's why this is successful, and that's why this is good. Like people can just like do LSCPU and see what kind of vulnerabilities they have, and if those are already mitigated because kernel provide that information. How trustworthy it is, we can ask Andrew Cooper tomorrow, or I don't know, maybe there are some expert from or like who know speculative execution vulnerabilities very well. Then we can also discuss about how good those how trustworthy that output is. So maybe Marek, even you know, because I don't know. Yeah. So the point is that we have to secure our ecosystem, and I have to say that proprietary OSs are already there, and they already have mechanisms, and these mechanisms they have. And the methodology they're doing that we cannot re-implement because they have like heavy NDAs. They have like a layer of compatibility. On top of that is a set of testing which check that given features are exposed by hardware, so operating system can deliver certain security capabilities. But below that is a secret NDA communication with the vendors, where directly with the vendors they agree if given property was exposed by hardware. And every vendor in theory can do that in different way. Like in practice it happens, they're doing this in different way because they're treating that as value added of this vendor. Of course this changing, one of the things that changed that is this group on the bottom, the ARM system ARC. This is of course group behind the NDA, but some people have access to that group. And this is their security sub-team who tries to change that. There was presentation by Stuart Roder, our security architect, on the last Dasharo developers VPAP, and he essentially said that this group trying to maybe unify that a little bit, but for ARM ecosystem. There were other talks about that. I don't want to go too deep in that. This is not the lecture, but yeah. And there are also other problems like Like for example, how we will know that we have SBAT, yeah, for security, UEFI secure boot revocation list. How in the operating system we will know correct SBAT was used with correct version, with correct certificate revocation list for UEFI secure boot. So if we will have your favorite IBV, your favorite is of course Tasharo, I know, but there are other people who got different favorite IBV, or they may use U-boot plus UEFI payload or other combination, and how we can make sure that Zen and Linux kernel will help to expose this hardware security properties for those combinations. It seems that they don't care. It seems that the only thing they care is proprietary UEFI implementation, and that's it. And they will talk only with that. So we have to think how to expose those interfaces and how operating system can claim something about security properties of the platform we're running on. Yeah, and LVS HSI, it is interesting. Yeah, yeah, it's yeah. I'm just like scrolling through my notes. The concept about LVS HSI is there is no consensus in community about this being the future of providing this information. What are the problems there? There is a spec which is not maintained. There are assumptions in the spec very close to x86 UEFI ecosystem based on the recommendation of the silicon vendor, which is not always good recommendation. Next thing is it relies on the consensus of UEFI forum, which we also not always agree with. And so that's why it is not really very community work, yeah? I think it can be improved. I'm pretty sure that Richard is open to that. But on the other side, I heard from Richard that he don't have time for maintaining that specification. So this HSI host security ID, which this specification defines what level of security your hardware have. He has no time for that, and he considering passing that to Open Source Firmware Foundation. And the question is, like, I guess this may be good for that specification, but the question if it would be good. And of course, all the hypervisor-based OSs are ignored. Yeah, so Proxmox, XCP-ng, Qubes OS, like, because, and it's even harder in those OSs because there is hypervisor in between. But on the other side, there are proprietary ecosystems which work in very similar architecture, and they have solution for that. So if we want to compete, if we want to deliver solutions like that, we have to find a way. And I don't think there is a better forum than this, or similar communities which has a lot of experts to discuss this and to get this going. And that's my point. We need assessment. But otherwise, we cannot say what's the security posture of our device. This assessment have to be trustworthy. Come on. Maybe come here. It would be maybe better because I guess most of the answers you should provide, not me.
Yeah, so can you go back to the slide? This one. So this first point shows some interesting problem here because sysfs and LSCPU, proc CPU info, etc. All provides a view from the point of that single VM. DOM0 is also a VM in Zen, which is different in Qubes OS. So that's another reason why just using FWPD, this HSI may not be the best way because it's a view from a single.
So you already agree with me.
It's a view from a single VM, and there are two problems with that. One. It may not always see what's actually in the hardware. In that particular case, I think most things are visible, but maybe not all. But there is another point here, especially about some CPU vulnerabilities that things that the Linux, the single VM has some things, some issue is mitigated or not, may not affect the whole system. We have different VMs and different mitigations at the hypervisor level. So, for example, VMC that one of those CPU bugs is mitigated in Linux. So maybe Linux will be able to like prevent data leaks between different processes in the same VM. But maybe it's not the case on the hypervisor level, and there are possible leaks between different VMs of the same system. Or the other way around. We have it mitigated between VMs, but not within a VM. So there are different levels, and it's also a bit different threat model. So you may be okay that your trusted VM, different processes in your trusted VM can like sniff data from other process in the same VM, because you don't have like all the processes there are trusted, and you don't hide stuff from one process to another in a single VM, but you care very much about leaking data to another VM of the system. Mm-hmm. So it's a bit different threat model.
Yeah, my point about, we will have Thierry in a second, but my point about the top one is not the methodology, because I'm not expert in speculative execution, so I cannot say if this is good. The outcome is very important for me, and the process they employed to achieve that outcome, because it's successful. So we should learn something from that. That's it.
Yeah, it's a follow-up question actually, because Xen is in the way. So after that, you have the kernel that is reporting what is supposed to be mitigated, but the information is not matching.
Yeah, so this is something that Linux is. This is actually one of the problem with this interface, because this interface does not talk to the hypervisor at all. It tries to see. It assumes it sees everything on the hardware, and in case of some of the mitigations in Xen, it's fully mitigated at the hypervisor level by simply either providing some extra mitigation, for example, when you switch context or switch between VMs, or simply disable some of the features in the CPU. And Linux may not be aware of that. So Linux see something that it's vulnerable to some of the issues, but it's actually mitigated on the Xen level, not a Linux level. So yeah, this is a problem with this interface. So
my question is, how can we mix those information so that we see that it's mitigated by Xen, so what Linux is reporting is actually false?
So this is something that Xen does report, but in a very inconvenient way. There is a message during Xen startup with all the list of mitigations applied. It's a text format. It's not machine readable. So yeah, then with I don't remember exact version, got an interface for reporting more of the information to the user space, especially to DOM0. Oops.
That's smart.
To DOM0. It's called hypervisor FS, Xen FS. I don't remember exactly, but it's an interface for providing machine-readable interface information. The speculative execution stuff is not there yet.
So we could merge those inside of a report at the end.
If I understood you correctly, you said that proprietary operating system already do some stuff. How does it look like there? Well, what are they actually reporting? Or
I don't know if I can we can talk not unofficially about that. But the point is there is essentially what's already
Windows or something.
Yeah, sure. So what's already happened? What GNOME. What this report does is very similar to what's going on proprietary side, very similar. Like there is some screen, there are some green stuff like that. So this is interface, but then behind what's going on, the difference is that for us to implement something like that, we need transparency from the bottom layer, from the hardware layer. We need some openness on the security features, spec or something, some public information about that. But the point is that vendors treating this as a value-added area, and all that is like most of that is proprietary. So
and every vendor has own idea how to expose this information.
Yes, yes, and then there is NDA between proprietary operating system vendor and the hardware vendor, so that information can fly and they can agree that the properties, security properties, are correct.
Do you have a specific example of what feature we don't have, like public interface, but
example of features? So SMI mitigation.
Okay.
Yeah. The RTM status.
Mm-hmm.
But
SMI mitigations, there are a special ACPI table called WSMT.
Yes, there are some.
But it's just information that firmware provides you what mitigations it has applied.
Okay.
For the SMI.
It is something at least, yeah?
Yes, there are some interfaces which are already existing, and there are some even UFI specification saying about way of extending this information, but this is not exactly always used. This is not standard way, not everyone complies with that, and so on. We can select some group, like let's say we can agree that Dashar will comply with that, but we would like to. We don't want to be the one who does their own thing, because there will be yet another thing.
Yes, but I think we should start not from the other direction. Like see what information we would like to get, and see if there is some API for that, or public or not.
Yeah.
Whatever.
So first three is like SMI, anti-evil-maid stuff, TPM stuff. So TPM stuff is also very important. What TPM I have? Is it like PTT or like some weird FTPM with some weird profile? We have no idea what it complies to. Or this is DTPM. Like maybe what DTPM it is? Is it like something with ROCA, or maybe something with ROCA mitigated? Like I know that I'm going to I can go even more with the details, but we have to stop at some point. Yeah. Mm-hmm. The discussion on
this particular thing, I think Linux already reports.
So, but this is spread around various places. You see, CPU was gathered, like all the vulnerabilities, many different vulnerabilities in many different CPUs and families. But somehow they were able to organize themselves and put everything in one consistent place. Yeah.
Yes, but there are still some cases where the same issue in different models are reported differently. So it's not. Not fully consistent.
Okay.
It is one place,
so
but it's not.
Maybe I don't have enough knowledge about all the possible combinations.
Yeah.
Okay. So I know there is like on VPUB when I talk with Stuart, he kind of suggested, like, he don't know yet. He's still looking for feedback, but he kind of suggested that during the boot process there will be mandatory reporting of various things to the TPM or DICE or whatever, to say, okay, like this is enabled, and it will gather those information in a measured boot stuff, and then if this will be standard way for mandated by the ARM specification, for example, or then in that way you can attest that. You can attest that from the system, because you have standard to which you can comply. But this is like his very rough idea.
Yeah, some.
But in that way you can.
Some wish about the future.
Yeah, some wish. Yeah. I think we have to get there, because otherwise we will not be competitive.
Well, with Trench Boot, we can include some extra information, however you would like to collect them in the measurement. This is something we already. On a different topic, we do in Anti-evil-maid. For example, we, in addition to standard DRTM stuff, we also measure, for example, the looks header, because it turns out it is relevant for the security of the boot process. So yeah, we add some extra thing to measurements, and yeah, we have the actually we have documentation.
Yes, Sealink is extended with also PCR13, which is supposed to have the lux.
Yeah, exactly. And we have the not very formal, but we have documentation.
But it's
what
not.
is
But
in the-
you see, this is not going exactly into assessment. It's going. It's. You have to then gather that, and I don't know if you judge if this is a good state. There is also.
We don't have any kind of remote attestation.
Okay, you're going.
Yeah, so we don't like. You know, if you look at your local system, just looking at the PCR values is not very meaningful.
Yes, true.
Like without any context. But we have some information, for example, for all the features we use in Qubes specifically, including if you have TPM. On the page you've included. So yeah, we
will have a separate design session about the screen. But anyway, I guess Simon wants to say something. And
yeah, what I was more asking with the proprietary OS was, what are they actually exposing to the user? Like, do you have to just some green checkmark, or do you really get some report like you have this vulnerability with CVE something not mitigated?
Yes,
what are they actually exposing?
Yes, that's a very good point.
To the user.
So they goals are not trustworthiness of these reports. Yeah, they rely on the brand and their certification. So,
but this is mostly for compatibility, I guess.
I don't
is
know.
This
they market that as a security stuff.
Okay.
So, and then based on these green marks, they provide other certifications, other types of certification, like a higher level certification of the security of the system. And I think they don't care about trustworthiness of that, because everything is hooked to their brand.
Yeah, so they have agreement that they promise this is true. If not, they will be kicked out of the program or something, right?
Yes. On the other side, the operating system, there are researchers, and if someone will find out that this is false promise, then of course there is a lot of food in, and they lost in revenue or whatever. No?
Yeah, but I don't think the method to collect this information is one thing, and the other is how to present it and how to use this information. And like now we have like 5 check marks there, or 6, I don't remember exact number, but we can probably add 1 or 2 more, but definitely not 20 more, because will be useless for the user. For the user, I think we need to have some standard or whatever that is correct. Is it good or bad, or maybe is it like 4 levels, but not.
I guess we will talk about design. We will talk about design of that screen in separate session. I'm right more about assessment.
Yeah, okay. But then I'm going in the wrong direction. But I just wanted to state that, or firstly, understand what kind of information can be exposed. For example, we have actionable information, like you have unapplied mitigations, and you should apply them. And this is something that should probably not be surfaced on the regular check marks thing, but maybe on the updater, some sort of information like, hey, there is actionable stuff there. And also kind of like surfacing some of the stuff that is static and per system and doesn't change through time on the HCL page.
Yeah, this is something that is getting more and more relevant right now, because there used to be a time where most microcode updates were some functional fixes, like there is this bug where some weird instruction can reset the system, and that's not great. But nowadays, most microcode updates are actually about security fixes in the CPU. So it's important the information whether your CPU still received microcode updates. And some CPUs are supported for 10 years, some are supported for 3 years, which is.
I had a hard time figuring out exactly like when they expired.
This is this information is quite hard to find. So there is this huge table with all the bugs and mitigations, and you have no information whether this particular is not CPU is not included because it's not applicable, or maybe it's out of support already or something. There is a page on Intel site where you have collected all the CPUs that are not supported anymore, but it's not exactly reassuring that, oh, I don't see my CPU on this page, so I guess it is supported, maybe. I didn't found any page like that on AMD, for example. So they have some security policy, which is very short text that, well, yes, we will provide security updates. That's all. Yeah. This is very relevant information, and we need to include this in our system. And I think this, this is something that is not changing. Like your CPU model is not changing. And I think this. HSI is not including this information also, because it's very hard to get.
Yeah, but you have also the UEFI security stuff. So UEFI secure boot stuff.
That's also.
That's something also. You're saying like you don't want to expose too much. Yeah.
Yes. Regarding the other security measures and features enabled, there's also the Microsoft HSTI, which I think we haven't mentioned, or do you have it on the presentation somewhere? It has it's a kind of set of bit fields that says about certain security features like UEFI secure boot, Intel boot guard, and stuff like that. So it reports the hardware security features
so you have
that are
Intel boot guard, also another thing.
Maybe
so you very
thing
quickly go into number of security mitigations applied to current platforms to make them reasonably secure, or even maybe that is not reasonable enough, is big, and you just like going. This is like a spectrum. You're just going from, like, you are somewhere in the spectrum and you have no idea where you are in the spectrum.
Yeah, and for secure boot it gets even more tricky.
Yes.
So you have some firmware that is using secure boot is enabled, and you have whatever, and then.
But the databases are not correctly populated.
Yes, or maybe you have in your trusted key set one of the keys that were leaked or something. So those test keys something.
Yeah, but that's my point. That's my point. The problem is very, very complex. But if we will not start moving, we will never get anywhere. Or if we should at least even try to fail, because like failure is also learning. I know that there is no resources, like we are always lacking the resources for that. But I think it would be very hard to compete on the market with hardware without this assessment. This assessment is really needed. You're saying you want to have limited number of checks, but then, and I agree for the UX perspective, but it has to be from one side. HSI goal was to give direction to buyer. Like, can I buy this?
Like 4 levels, if I remember correctly.
Yes.
There is
5 or 6 even maybe.
6?
Okay.
No, 6 not.
No, I think
maybe 5.
0 to 4.
Yes, there is 0. Yeah, 0 to 4.
0 to 4.
This is. I just wanted to propose an idea. It's probably a bad idea, but this feels to me like it. I mean, we're talking about a relatively small niche. But maybe this would be a place for an organization / company to do the certification, or to have this kind of levels and then do the assessment, and then they output the final.
I already heard that one. Yes, that's one of the options that some people propose. I'm not sure if this is good.
Me neither. Just for the record.
The best would be if there is if the operating system expose that in a standardized way, which is implemented in community project like Linux and Zen. That's, in my opinion, the best way, because there are already companies there which would have to agree between each other to merge those patches, and that's important exercise. But I think that also in that way also can be blocked. No? Okay, we are end of time. We will talk about this topic also more from UX perspective on the session related to Qubes security report.
Okay.
Okay, thank you.
Thank you.
So hello. Yeah, first of all, I'm Nestia on GitHub, or Hannes. I work for NitroKey. And yeah, the talk I'm gonna give is more like, yeah, as it says, exploring some concepts. So it's really not any kind of finished thing. It was more like a question. We discussed it also at NitroKey, had in mind, okay, how to get rid of like passwords also within Qubes, because Qubes is like most of our product, like especially the NitroPads, are shipped with Qubes. So that's a big question for us. And so from this starting point, yeah, kind of the adventure started. So what I will talk about is this, and some guidelines I set myself in which direction I want to go. Then I will talk about some like the concept actually I came up with, maybe mention some other stuff where I went into but not really in depth. And then I hopefully will have a working demo. Let's pray to the gods. And and then I also really would like to have feedback from you, and also a discussion about, because what I basically are gonna show is really some raw thing which is not really usable for like normal users, but I actually think it's a good idea to kind of bring it more in this direction. But maybe somebody says, hey, that's completely bullshit, and then discuss about this. Yeah. So what's the problem with passwords? Yeah, that's one, we forget it, and then we have to rename our dogs. But another problem is actually that, for example, when we travel, we are on a conference like here, we often are in environments where we actually cannot assure that somebody is not like looking on our keyboard, having a camera out. Actually, microphones are actually also a pretty big problem, because we learned in recent years that even the sound of typing gives away your password. So there are a lot of problems, and if you want to like start your environment, you need to type in your password. So yeah, additionally, we would like to have some solutions for that. One solution is this, which I'm not going to talk about, but I think it's neat. So what? We can discuss this. If we have free time in the office, we can actually maybe produce them. I'm not so sure about this. But we can try. So that was a low-tech solution for that. But yeah, another solution is actually to add like a second factor to like secure your data. So you have a password and something else. And so something else, yeah, could be, for example, a Nitro key or a kind of token. Could actually be also a second password, but that makes not so much sense if you want to get rid of passwords. So yeah, the guidelines I set myself is that I really want to stay as close as possible to existing Qubes like default installation and make it as seamless as possible. And I don't want to kind of like switch off some security features in Qubes. That is actually also the reason why I'm not going into like decrypting Qubes by itself with the Nitro key, which is quite possible. But for that, we would need to disable the USB basically block for DUM0. Not completely, I guess. I think there are ways around, because actually you just need to disable this for the init RAMFS state. But yeah, I looked into it. It actually worked. But yeah, you have to be fine with the USB stick exposed to DUM0, which for a lot of good reasons you shouldn't. So software I looked into, yeah, basically is the system decrypt enroll, which is basically used to use this FIDO devices to decrypt your looks header, and with that your looks partition. And also I looked into keepers X, and actually I will use basically kind of like foreshadowing for the demonstration maybe. I will use Keepers X actually because I really like the split SSH setups we have in Qubes, and I actually at some point, we're at the point where like, oh yeah, I can actually do this also with like decrypting Qubes. So what is the basic idea I came up with? So when we look at Qubes, what we actually want to like where's like our data, and our data is in every cube we use. If you use disposable cubes, that doesn't matter. But all our data we actually care about is in this /rv thing on an extra partition, which is kind of nice. It's on an extra block device. It's on this XDB block device. So basically, what I was looking into is, okay, I start Qubes with my password, but now I'm actually want to encrypt basically everything which is on this block device with a different factor, and how to make this kind of a nice, seamlessly experience. So this is what needs to be encrypted. For that, what I did is actually I need to do some changes to the templates. They might in some places not be necessary, but because normally in the template it mounts this other block device as his RV thing. So I want to get rid of that, because otherwise I would have to decrypt the stuff in the template already, which didn't make sense to me. So I mounted it as tempfs, which is quite a light change. It's just one line. Then I actually activated RC local. This can actually be probably done differently, but it was the easiest way for me, like for the automation. And basically I have two scripts which are there for creating and for open the encrypted home. And that is missing here, I realized, for the split lux, I call it now, maybe it's not the best name, I actually added some QRX service, basically, like if you are aware of how split SSH works, it's basically kind of the same. It's not using the socket, but yeah, it's kind of the same. Yeah, I come to some other ideas later. So how this works, and it actually works quite well. The initial encryption of the home is like, you just look, okay, is XCB already formatted? No, okay, let's format it. Are we in a template? No, then let's format it. Yeah, you will see there were some learnings. It's a good reason to do that on test hardware. Yeah, then open it. Then if we want to use the FIDO device, then we obviously attach our Nitro key, our solo key, whatever, to the app, and then just run this system crypt enroll thing. It really works seamlessly, kind of. Then we need to create the file system, and actually then I just copy the old file system to the new file system because I'm lazy. There's probably a better way to do that. And then I switch off the VM because that's kind of the initial step. And from now on, every time this VM starts, crypt setup opens this data. Here also again, if you use a FIDO device on startup, and here you come to the point why I actually then later use this Keepers X, because on every startup, on every VM you have to do that. You always have to attach the Nitro key, maybe with these changes that you can kind of automatically or much easier attach a Nitro key or a FIDO device. That actually would make sense to go more in this direction and then decrypt it. Yeah, the lower part probably can change a little bit, but because normally, like, the FVM starts and it starts the user session, and I didn't want to go too much into systemd stuff, so I let it do that. And so I need to kill the user session, actually remount home and user local and then make some SE Linux stuff, which needs to be heavy. That's actually quite easy because you just need to restart something. And you also just need to restart the Qubes GUI agent. And then actually it works. So that's like from the technical point here, what's happened. So, and as I mentioned, I had the setup actually also with this Nitro key, and then I was like, okay, that's all nice and nice, but I have like, in my normal working setup, I have like a lot of cubes, which I regularly start and stop and start and stop for a lot of different reasons. And I actually don't always want to attach the Nitro key there and start it again and so on and so on. So I just want to have this whole, okay, second factor thing existing like for one time after the boot basically. So then I came up with this, or this idea came to me because split SSH with KeePassX works a lot in the same way. Okay, I started, then I start my vault, I open KeePassX with my key, because that's actually a quite new feature nowadays, that you can do this via this SHA-1 HMAC security challenge. And then actually this KeePass database is open, which has like a long password in it, which is used to decrypt then the home. KeePassX has a nice feature that it can be used as secret service in a OS. So actually you can ask the KeePassX, hey, give me this password. So this is a mechanism I use. And then it's basically the same again. So with this, I actually now can kind of seamlessly start these cubes again and restart them again, and also have like kind of like groups of cubes which are differently encrypted. For example, I have work, I'm a journalist and I work on this article, and all these I have, for that I have a different KeePassX database. In this database there is this encryption key for all the cubes I use regarding to this work, but then I have like my presentation, which I go use in a conference. It's in a different KeePass. So like the password for that. And so with this process, I actually can have like a lot of spheres which are differently encrypted. And actually when my laptop is, for example, taken from me or whatever, somebody watched me typing my password, I actually can ensure that I actually maybe not able to decrypt certain parts of my Qubes installation, because I don't have maybe access to this one KeePassX, because I don't have the key which is used to decrypt that with me. So with that, it gives me like a lot of flexibility and erases probably the need of have like a lot of different hard drives lying around, and I can all put the data in one system. So that's basically the idea behind it. So now it's time for demonstration. So what I will demonstrate now is basically the whole split Lux. Maybe this is really not the best name, but this whole setup. So I will use a template, a special template to create a cube, then initial starts this, and then we will see how this initial starting goes. You don't see much because there is no UI at the moment for all that stuff. And then in the second round, I start it again, and then you see how, I basically will show you the mount that you see, okay, it's actually encrypted device. So maybe not so spectacular, but yeah. How do I get away from this? No. Oh. Let's do it like this. So the first thing I'm doing is searching for USB port. So there it says my Nitro key was available. So the first thing I do is actually start the vault, because I just started the laptop. Yeah, for whatever reason, this needs to be done. So this starts the daemon to restarts the daemon for keepers X to be able to kind of find the Nitro key. We need to find out why this is needed, but so I connect the Nitro key to the vault, and then I start the keepers. It sees that, so I just can say unlock. And here you already see I have here's a password. I can show it, it's like this. Don't use this password anywhere. So basically it's a password with a special title. So what my script is doing is basically search for a password with exactly that title. So now I'm the Qubes create. Again, really thankful for the whole redesign stuff. So here I have the special Fedora template where I just did the changes I told you. Maybe call it demo. So we create this. And now we have it here. Now we start it for the first time. And if no, it will not work. This will work, but another thing will not work. So let me just, we need to enable this, and for whatever reason, GNOME keyring is really eager to, you see it's proof of concept. So now we enable this as secret service. And so now it's the first time, so it takes the password from here to basically format XDB, and then it shuts down basically. So we wait for it to shut down. Actually, not sure why it asks there twice, but so it now shuts down. But now it's basically a cube how we want it. And now we start it again. It asks, let's see this pop-up here. And now if we start a terminal, for some reason I had to put a timeout for sleep for 10 seconds before I start the GUI, but here it is. Now if you see mount, you can see here that we actually mounted DevMapper data, which is an encrypted, home basically now.
What happened to your home directory? You are starting in slash.
What?
The current directory is slash, not home.
I'm actually not sure why this is happening, but we can go there. I think there are a lot of things going on here, which is probably not the proper way of doing it. So I guess to just restart the GUI is but let's go back to the presentation, because I have the point of what is actually not working and what is maybe also not really the way to do it like this. So. There we have it. So known problems, no GUI for whole the thing. No error detection actually, right yet. Resizing might destroy it because Qubes resizing is actually working quite nicely, but with that another layer is added. So so that's basically something which needs to be addressed or at least kind of locked. And yeah, the whole thing that I let the user session start before I decrypt it is actually probably not the best way to do it. It was just the fastest way to like kind of show that it's working. This is probably fixed by having some systemd service run much earlier to do the whole thing. And then we actually get rid of this whole Qubes GUI restart stuff, I guess. Also, which I have actually now. But what I wanted to show is it's possible and actually quite easily implemented in existing Qubes. And I really like the idea of this feature. And so, yeah, my question is, does it make sense? To you, but also what I didn't really look into much is there is this existing split two-factor authentication feature. This might be actually quite easy to be connected here, and also maybe helps with maybe then this whole keeper thing actually doesn't need to be there, and is even maybe a bad idea. I'm not 100% sure about this. But this is a way to look into it. And actually, I think it's the talk after me about the whole salt stack and so on. So basically what I wanted to do till now, which I didn't manage, is to actually have like a whole salt configuration for that ready to just be installed like this. But yeah, that's the idea. But yeah, basically, that's it, and I open for questions and suggestions in this direction.
Okay. Thanks for the presentation. I have two questions, maybe more. First, I remark, yes, adding some systemd dependencies to start it before GUI extension will avoid this issue. It should be just fine. But first is, yes, split, it's called split setup now. It used to be split FIDO2. Is it called, is KeePass using specifically FIDO protocol or something else? Because this split FIDO thing is providing FIDO protocol only, not other features of Nitro keys. So that
no, the system decrypt and raw specifically used FIDO, so I guess there you would connect and you would leave the whole keeper thing out because KeePass uses this SHA-1 HMAC challenge thingy, which is, I guess, not connected to FIDO. So yeah, so if you would look into that, then it would be more like, as an addition to KeePass.
Okay. And the second question is more complicated about the basic design here. So this is decrypting the data partition from within the VM.
Yes.
Have you considered doing it from the outside, like in the DOM0 to provide some device that VM already sees as decrypted, like it's done transparently for the VM? A bit more context, we do have kind of support for similar thing for swap and non-persistent partitions. There is a ephemeral volatile something property you can enable it. It will provide a looks encrypted device with a random key that gets discarded each time. So it could be maybe extended with some static key that is persistent and stored somewhere. But it means you have some extra code in DOM0 that need to talk to some parts, maybe also to the key pass using some API. Then probably you won't be able to use like this system decrypt and roll, because we don't want that in DOM0 talking on the VM data. I don't know. Have you considered both cases?
I have considered both cases, but yeah, for me that came really clear. Okay, I need to change stuff in DOM0. I actually also need to change stuff kind of to the core, how Qubes is doing stuff. I actually didn't see this feature. If I would have seen it, maybe I would even go more in this direction. And for me, it was really like keep it as simple as possible to be implemented on existing Qubes. So changing stuff in DOM0 really was kind of a I don't want to touch it thing. Okay. Because of that, I didn't look into it. But I would say if to implement it like deeper into Qubes, it totally makes sense to do it like that way, transparent to the app VM by itself.
Yeah, doing it from DOM0 has one more advantage, that it doesn't depend. VM doesn't need any integration, so you can also apply it to Windows VMs, for example. Which with the current approach you would need some separate installation. Yeah, so some things to consider, but it would need to be significantly different, I would guess. Yeah, maybe. I don't know.
Hi. If I recall correctly, there is some guide somewhere about using a nitro key to unlock the user login on DOM0. Have you looked into that at all?
Yes, there is a way to do that. Again, it's changing a lot in DOM0, so because of that, it kind of fell out. And you actually, I think they kind of using the C-tab.
I think it was the C-tab, yeah. So it kind of scooted around the attaching it directly.
Yeah, and you need to enable stuff on the PAM level, but it looked quite workable. I actually not really were going the full way of trying it, because it was like, okay, actually I also don't want to like secure the login at this point. I wanted to have really a second factor, and the login I didn't really consider as a, it's like if you have a live CD, you don't need this whole login thingy. So that would be, but it's an interesting idea for like environments where you say, okay, actually we have multi-user Qubes installed, which is maybe an interesting idea for this whole Qubes Air thingy. Yeah, but I guess it works. That's the whole thing. You can make the whole system like use without passwords, but for that you need considerable change DOM0, and actually maybe also a little bit too much as you may want.
Yeah, and for that, another question which also leans more into that direction. On the initial LUKS decryption of the DOM0, have you considered maybe using something, as much as we love nitro keys, of course, maybe a smart card or something like that, which would mean that we don't have to expose the USB to DOM0?
But usually smart card reader is also a USB device.
Yeah,
it's integrated on the board itself?
Usually it's also a USB device.
So the risk would be...
connected to internal hub.
So the risk would be someone could desolder it and use the pins as USB and then use... Okay, fair enough. Thanks.
Thanks.
For this problem of not exposing the device, and also what you didn't talk about, also that when you are sharing your USB VM with different devices, they would potentially also could get access if they can exploit something in the USB VM. If you have custom firmware on your token, then you could establish some tunnel to the token, and then that obviously needs some customized token, which is a big step, but then you could kind of get rid of the problem of exposing the USB part. So you have some QRXEC tunnel to your sys-USB, and over this have some authenticated encryption, so that you can talk to really your Nitro key and not something else.
I actually think that's what the split CTAP thing is doing.
No, I don't think that's
No, it
secured
doesn't-
against tampering from sys-USB.
Now I get it. Yeah.
It could indirectly. CTAP and FIDO and FIDO2 provide also a device attestation. So when you generate a key from your token, you get also certificate that it was actually generated by token produced by Nitro key or by UDT or what other companies. You have certificate attached. So you get the key origin this way, and then only that token has a private key. So when you authenticate later, you are sure you are talking to the.
Do they authenticate and encrypt the communication? Because for the such
communication itself.
Yeah, but for this you need some static secret.
Yeah,
so
for static secret it won't work.
So I don't think that's probably only working for this remote authentication where you interact.
Yeah.
That secret is not on sys-USB, is it?
No, it's on the token.
No, but
in this case,
looks
yes.
you are exposing it.
Yeah, for in this demo, it was in KeePass, the static secret.
Yeah, but that's on sys-USB.
Use mine.
Oh, sorry.
Sorry for YouTube. It was interesting. Not have to be here. Sorry.
So two basic questions, I think. So one, the reason you can't do the full disk encryption safely is because you need to decrypt the disk before you can start a separate USB VM. Is that fundamental to how Zen works? Or is there a way around that?
I actually did not look into full disk encryption because in my mind, it doesn't really make sense because it's like these templates. I guess you can do full disk encryption with Zen, but I'm not 100% sure how. Now with the kernel at least not, I guess. But I did not look into that because in the end, it's only the data and kind of the template. I already assumed that it's already safe. For sure, if you assume that your laptop as a whole got compromised, then you shouldn't do anything of that.
Mm-hmm. Okay. And the second one's related. Are there any problems with having looks on looks? So nested, no performance, nothing. It's transparent.
Probably a little bit performance, but I did not measure it. But I don't see why there should be bigger problems.
Is it routinely done elsewhere? Do you know?
No, but I do it quite often. I'm not aware of like this, but I don't see problems with that. I guess actually in server environments it's more often done, but I'm not 100% sure.
Are you aware of the interface that are provided by KeePass.exe?
As a secret service?
Yeah, can you actually generate on demand based on the name of the VM, for example? Can you?
No, it's really just you talk to them and say, hey, I search for a password with. You can give them a little bit pattern. It's not like please create that for me, but I'm not 100% sure. It may be bugged. I didn't look too much into that, and actually. For security's sake, I thought about that actually, but I was like, okay, now I really want to be that in a one-way discussion here, so nothing can change the password and keepers. At least I hope that this is the case. And it's my assumption here. Maybe a good thing to recheck that, because it basically uses this secret service API, which I think comes from GNOME, but I'm not 100% sure.
Because I see like the next step being a service provided so that you can create like VM automatically talking to KeePassXC, because you hard-coded the enc like in your thing.
Yeah.
But like each VM could have like their own keys registered automatically, and then since you connect your FIDO key to authenticate inside of KeePass, then your vault is open without typing any password. And then I was just thinking what KeePass can actually provide.
Yeah, I think there's definitely room for automation. I'm not sure if that KeePass would be then the right direction, or maybe something else. Yes, but it gives you a lot of things to play around with.
It's supposed to be a discussion, right?
Yes.
So I have some to
Yeah,
something
no, that's fine.
to add to
Use the mic.
So I think the secret service, the API, does provide some way to register new secrets, so it should be possible. And the issue you mentioned that you want to be in one way, I think you still can do that by having two QRexec services, one to generate a new secret and one to get a secret for existing secret. For example, so the one that generates would take, VM demo is asking for secret, so let's generate if not already exist and fail if already exists, or something similar. So that should be solvable this way, yeah, I think. And I was thinking a bit more about the systemd dependencies and not killing user session and stuff. Actually, there is tiny problem there. Currently, QRexec agent inside the VM is configured to start after home is mounted. So you have a dependency cycle there. So no, it would not be a simple change, but it could be done, I guess.
Yeah, I actually encountered that. That was the whole way, because I did like this home, make it tempfs so that there is some home and stuff like that. So yeah, but really it's proof of concept. So there's a lot of improvement.
Great one, yes.
And actually, yeah, I will put the code somewhere next week, hopefully, on some kind of GitHub repository there. Actually, yeah, I'm really looking forward to Ben's talk, because actually because of that, it's not there, because of what I wanted to do is like to provide the salt configurations. Maybe I'm also able to do that after the talk from Ben. Yeah.
So I guess an idea for hackathon time.
Yeah, I also thought about that.
Okay.
Thanks.
Hello, my name is Benjamin. I'm going to present how to architect Qubes OS with Salt Stack and why it's easier than you may think. So, what is going to be done? Why I think this talk is important. Like, for example, why backups don't fit this role, why shell scripts, they don't go well to manage infrastructure, and you should use proper infrastructure as code tools, how to architect using best practices, how to do basic salt states, and customize your states. The bad times when you have with salt, contact, preferences, and Q&A session. So I'm a fast maintainer contributor. I like to automate every task. I like to do trail hikes and table tennis, and I have gear if anyone wants to play in the break. So the code is licensed AGPL 3.0 or later, and the documentation is CC by SA 4.0. So the code is used to fit the slides, else it would look too small in the slide format, and it's not a complete explanation on how to architect Qubes OS and use Salt Stack, just the basics, just an intro. So I want to harden Qubes OS defaults. I understand why Qubes does what it does, because it can't be the most hardened and at the same time the most usable. And I would like to automate workflows between Qubes, because that's a nice, powerful feature of Qubes. It's the QRexec. And I want to replicate the setup easily on any machine, on my machine, on multiple machines of different people. So Salt is a configuration management system where you establish a state that you want your system to be. And it's also a distributed remote execution system where you execute commands and query data from minions. That's the Salt terminology, and we will call them target or cubes in this presentation. So some alternatives are Puppet and Chef. They don't have native integration in Qubes. Ansible, there was going to be a talk tomorrow, not anymore, unfortunately. And shell scripts, they are way out of the league. They don't fit, and if you try, I'm going to show it will be horrible. So Qubes has the powerful QRexec framework. It's a protocol, it's a client-server model. You may know on other systems as remote procedure call. It applies the principles of security such as usability, separation of duty, defense in depth, minimize attack surface. And the policy you may know on other systems as identity access management or ACL, but in this case, instead of users, it is Qubes itself, the name of the Qubes, and it applies principle of least privilege and secure by default, for example, not allowing connection to TCP ports to other Qubes, but allowing clipboard, copy and paste. And I like the Qubes philosophy of being open source and the security, because they focus on security and not other things. For example, for privacy, they let Unix handle with that. So what Qubes brings to the Salt execution, it is a master minion, so there is no connectivity to DOM0, and for that it uses a disposable management cube that it holds the Salt package and connector. You can see on this how it looks on normal system, and normally it is done with SSH, while on Qubes there's a target system where the state is copied from DOM0 and then to the target, and the target applies the state to, it is copied to the management cube, and the management cube applies the state to the target. And by this way, there's no way to, for example, to return escape characters to DOM0 directly, because they are sanitized by QRexec. So why automate? Because I think infrastructure replication should be done to always have a constant and consistent system on every machine, because backups are time consuming and they don't aim to create a state. You just restore your old infrastructure, for example. And I consider Salt Stack high readability. It uses the Qubes API and it's built for dependency, where you apply a state and you can reapply it without a problem. You don't need to do logic to check if the state is not in that correct sense. Salt does that for you. And you can back up your state in code and not store, like, for example, template VMs and a lot of data that's not necessary. Of course, you should do backups for data that's important. And because automation is fun. What led to the status quo of shell script? I want to take some moment to that, because people still use it, unfortunately. I think it's both because most community guys, they use tutorials with shell scripts, and people try to improve upon that instead of changing to other tools such as Salt. So please meet John. He loves to manage his cubes with shell scripts, and he denies it is a double-edged sword, because he makes coding mistakes and the computer doesn't care what you think. It just returns the output. And then he complains to the forum, to the mailing list, to the GitHub issues. That's Qubes' fault and not his fault to choosing the wrong tool. So Alice, she's been through that, and she wants to pass John, helps John pass through the grift. He'll go through, Salt has bugs also, it's Jinja bad, shell good, and no way, shell scripts through, and okay, I'll use the Python API, I'll code directly in Python, and then after some time, we'll notice that's horrible because we're gonna have so much more things to think about and much more code to read and to understand. And most of all, I think it is not shareable, because if you share a Salt code compared to Python code, it's much easier to grasp the code reading in YAML than when it's read on Python. The same thing then, I hope John, through the end of this presentation, he accepted it's a better thing to do. I don't care if it's Salt, it could be Ansible, could be Puppet, could be Chef, but it needs to be something that's not shell scripts. So Alice lists some nice features to John, such as declarativeness, where you describe what you want your assistant to be, and you let the program handle the rest. And readability, where it's YAML and Jinja when necessary, and I also don't consider it readable, even though Python developers consider it and they wrote it, so yeah. In the content, you get consistent results focusing on achieving the same state, and imports, for example, you can, the same thing as you can source on a shell script, you can import other files, other formulas from yourself, from cubes, from whatever you want. And you can target different cubes by rows, regex in their names, and grains. Grains are important because they're properties that can only be cured after boot. But John thinks those are only fancy words. Yeah, so Alice sets a task to do in Salt and compare to shell scripts, such for example, install tunar and GDK pixbuff, and it must work on Debian and Fedora, and must only install the necessary packages. So this is how it would look like with shell scripts. First, there's no syntax highlighting. Second, you have to deal with codes and variables only expanding inside the cube itself. And third, you have to understand how DNF and APT works. You have to search for the correct options to make it non-interactive. And the last thing, I think it's the most important one, with Salt, you have the result logged to .0, so you can see what happened, what failed, what version of the package was installed or uninstalled, for example. And this is how it would look like with Salt. The first part is the Jinja section, where you get the package depending on the OS family. So if it's Debian, it could be the Ubuntu. If it's Red Hat, it will also fit SUSE, for example. In the second block, you can see I'm calling the package installed Salt state module. I'm saying to skip the recommendations, skip suggestions. I have to use setup to install wikidepth, because that's unfortunately something not supported by Salt by default. And then I get the previous variable package in the package section, and I put it to be called in the package list. And this output is logged to non-zero. You can see what happens. You can see how it goes, and you don't need to deal with codes unless using Jinja. Yeah. But John wants another round. So they try again, but with creating a cube itself. Like, for example, creating the DVM browser, which is a template for disposable VMs based on Debian 12 XFCE, and it's labeled red. This is how it would look like with shell scripts, where you have to do a negating check if the cubes already exist, because if it doesn't exist, it will create successfully. But if it does exist, then you have a return code of 1 and non-zero exit code, and that's a problem. Then you check if the variables is already set to the desired value. Because if it is not, you have to set them. And then you have to do logic and if-else statements. And this section only is not bad, but imagine this multiplied into multiple cubes and multiple preferences, because this is only three preferences there. So it would look worse in a bigger scale. This is how it would look like with Salt. I call the KVM template installed Salt module, and I just say to Salt guarantee the template is installed. It deals with the rest. Then the second section, I call the QVM VM Salt module. that is created by Qubes, so also the QVM template installed. I require the QVM ls installed Debian 12 XFC to have returned successfully. So I guarantee that this cube can only be created if the template of it exists. And then I set the preferences. I also set the present and the prefs double, the template and label, because I want to ensure it's on the correct state. The present is during the creation of the cube, and the preferences is after the creation of the cube itself. But okay, bored, already convinced, you already know Salt's better, but that depends on what you want to accomplish. Like I had a lot of ideas of what to present here, but I thought starting with the basics are the most important than trying to explain something very difficult that only a few people in this room would understand. So, some steps that I think are necessary: design the architecture, set the rule for consistency, readability, and reusability. Those are things that you can find in the Clean Code book by Bob C. Martin. And also try it out multiple times, because you only get better after you try multiple times. So, study Salt, Qubes OS, Target OS. You have to have an understanding of how it works. Else, you will try to find how to deal with a problem that doesn't exist, because you don't understand how the tools work. So read the manuals. Think how the tasks can be divided into multiple cubes, because that it is the cube's powerful statement. I want isolation, but I also want communication. And I lead, for example, the dangerous things to disposable cubes, and then returning to app cubes, for example, to store data. Sketch or write freeform text, whatever you prefer, use on an online site, type on your computer, how this can be worked. Document your design choices, because you're going to forget. And then after you've done multiple formulas, your formulas will look like crazy, super different, so you have to document it. Declare the state and apply in test mode. It works to some extent, because other states may require the previous state to have a return value, and apply the state. And please note, this is independent of Salt. This is just architecture, so it could work with Ansible and other tools. So, notice that template VMs are useful because you can have offline cubes based on it. Instead, when you have standalone VMs, it is difficult to install software when the standalone is offline, because you have to enable networking to it, install the software, disable. And with templates, you don't have this problem. You can use the proxy, for example. For user interaction, focus on using disposable VMs for data processing and app VMs for data storage. And the admin VM has some usability, but not good enough. The QExec policy isn't restrictive enough to work in a multi-VM setup. For example, if I want a certain state to only be applied to certain cubes, that's limited on this case for QExec. Why? Because you can glance over the code and understand how it works. You don't need to spend a lot of time. If you know how one formula works, you can understand how every other formula works. Consistent names on the documentation, state declaration, always declare your states the same format. Use macros, file hierarchy. Separates your states into directories. For example, use a files directory. For the admin states, put in admin directory. Make that something that you can understand and not have a lot of files, like 20, 30 files in the same directory. That will be hard. So, reviews. Macros and includes, because you're going to find code duplication, so you need to use macros in Salt, or at least it's better than have code duplication. CI/CD, it is kind of difficult. It's possible to lint, like for example, Salt lint, PyLint, shell check, but the problem is you need a Qubes workbench to lint your code, in the sense that you can test it also, and that is sometimes hard, because you can write your code outside of Qubes, but you cannot test it. So, this is a state module. As you can see on the second line, QVM template installed. This is a state module, a state that is inside the file, a module that is inside the state file. And the execution module is the state apply on the last line. It is a module that calls the previous Salt file to execute it, everything. So you're going to be using both, and all the execution modules and state modules, there are many, but I'm just showing an example of how they work. now I picked this Alice. She's from the How to Organize Your Cubes, from the Cubes blog post. She has her workflow separated into multiple cubes for different clients, and she uses the client B code to write her code and client B build test to test her code. But copying one code every time she needs to test the Git repository from one cube to another, it takes a lot of time, and she wants to make it better. So she designs a system where the build code can fetch code from the client B code. Sorry, the build test code can fetch code from the client B code, but it cannot push it. And if you notice, I also use Alice also in the name instead of the default cubes, because you need to know from which source, from which origin your code comes from, because sometimes you can have formulas from multiple people and the service's name and policy could conflict, and that's not good. So I think it is better if you put your name, your company, or whatever, something that's informative to you. So this is the pseudocode all over it. Just to explain, the first file is the Git remote helper. It communicate using the Git remote helper protocol. The second is the QRexec service itself. And the third is the QRexec policy, where you can see the build code can only fetch the repository B from the client B code, but not from any other repository or from any other cube. Just a moment. So this is a state module, a state file. It calls the package installed, and it says to refresh. It says like package apt up to date. And it don't install unnecessary packages that can come with Git, and it installs Git at the end. That's simply it. But if you have multiple files, multiple packages, you would list them below Git. So remember the previous state, it is ls git install. You reference it via an include to not have code duplication. You set the Git execution path. It's different on different systems. You can also use another file from that. Just because of slide reasons, I put in the same. And then you install the remote helper. You require the Git was installed to not have any problems. You source from the SRV salt Alice path. And you can see the path is Alice files, Git client, Git remote QRexec. You set the mode. It's better to enforce the mode than let it be, and let the system choose the UMask. And set the user root and make directories. And it's also the same thing for the Git server. I just want to show through repetition that it is always the same thing for file management. Same thing for the Git policy. And I just want to make a note that you should not edit 30 user policy. That's very bad. Edit anything that's above it. Normally, the recommended 60 to 80. Yeah. So how would she apply those states? She calls the alice.git policy. You can notice that the dot is a salt nomenclature. It is also the BEF division in Unix, you'd know as slash. kubectl, state apply, and the path to the state that you want. And for in this case, for the DOM use, she applies to all the template. She skips down 0, and she lists the state separated by comma. But that is not good enough, because you don't want to list every time the states that you want to install and the cubes you want to apply them all. For example, if you have multiple states and multiple formulas, you can use a top file where you put a state in the high state. In this case, you'll see I'm matching DOM0 by node group, and I install ls-git policy to DOM0. While for the templates, that is a I-at, it is it's a pillar, it's a salt nomenclature for the cubes type template pillar. And if it matches the grains OS family of Debian or Red Hat, it's installed to those templates. Then you can see I enable the Alice to the high state, then I apply to every cube. So I don't need to worry about which cubes the person has in the system. I just apply to all, and the code is only going to be executed in the ones that matches the directive there, the high state. So, but the problem is Alice ends up producing many more formulas. In the first, it's Fedora 39, then later Fedora 40. And it's okay because it's 6 months. She will remember to update. No, she will not. When she has 50 formulas, she'll forget, of course. And she wants to do better, so Pillar Swift Ginger to the rescue. You can see the first part, it is a pillar. I declare the Alice template Fedora version is 40, and the same thing for Debian version 12. And I also use a top file to enable that pillar. So for example, if you have there a variable to declare, use pillar for that. You can enable customizability. For example, you can have a formula that when different people want a different setting for them, you can customize it by pillar. And now it looks ugly for me, but it is what it is. It is how Jinja works. You call the pillar get module of salt, and you declare the pillar that you want to get. And then after the comma, it is the default value if no value was received at all. And for example, I'm going to create a state to install Fedora, only Fedora in this case. I import the previous Jinja macro, not the macro, just Jinja statements. And then I use it using variables. So I only have to update one file or one pillar, for example, to have every other formula reuse it. But what would you, if you would create the previous Fedora, a cube based on Fedora, for example, the example cube itself, and I want to use the previous state Alice install Fedora, and I use also the variables again. This would not be necessary if I name my templates differently, such as template yellow, or something that doesn't contain the Fedora version in the name. So to enable the pillar itself, you put it in a high state, and you finish with pillar, the parameter pillar equals true. And then you apply the state that you want, and it will use the enabled pillars. And the properties will be enforced. So it ain't all sunshine and rainbows. OS support is not as good with Salt due to Fedora release cycle. So that's a very big problem when it occurs due to Python version. I believe Red Hat does better with Fedora and Ansible together because she collaborates on both. Troubleshooting syntax errors of Salt, it's horrible. Sometimes it indicates the line number and the column number, and when it doesn't, you are lost. Even if you fill in the file, it's not clear. Real-time output, Ansible has this one, Salt doesn't, because the output is only returned from the target after the call is finished. So, in summary, shell scripts are strongly discouraged. Don't bargain for infra, use the best tool available, use tested tools, don't use shell. Design and document the architecture before coding, be consistent throughout your designs, and you can only do that if you document your design, and apply best practices where you can on every step that is available, because it doesn't matter if you use Salt and you don't do a very good job at it, it doesn't matter at all, it's bad code in the end of the day. So I did something which is Qubes, Salt formulas for Qubes OS. Many of the things I would like to have shared here, but it simply doesn't fit the slide format, and people would not get it. So if someone wants to take a look, you can find on my GitHub that is going to be linked later on the references. This is my contact information. The references, I would also like to mention Uman, because most of the Qubes formulas in the beginning were based on Shaker, which he has been providing for free for the community for more than 2-3 years already. And Qubes is on the last link. So, any questions?
I have one question to one of the slides.
Yeah.
You showed the top file with targeting based on grains. This one. Does it actually work?
Yeah, I use it like this.
Okay, because I think we had some optimization to skip, to not apply to cubes that have no rules to apply, and to not even start this disposable VM. And I think DOM0 doesn't know grains, and especially this OS family of the target cubes. Maybe it works because it takes OS family of DOM0, which is always Red Hat. Maybe, I don't know, but it's interesting that it works.
I'm sure it was at least working like 2 or 3 months ago. I'm sure because I was using that, for example, and it would be skipped in Arch Linux.
Okay, so it was not. It was skipping Arch Linux, but interesting.
Some months ago, yeah.
Okay.
I don't know anymore. So
okay,
then.
interesting. Thanks.
Okay, so yeah, I have a lot of that. But let's start with testimony. So thank you very much for this talk. Great talk. I'm using Kusal for I don't know, since it was published. It was published around a month after the Qubes OS Summit 2023.
Yeah.
So a month after my lame talk. Because this is wonderful thinking. So if someone will dive in the code and look at the architecture, it is really great. So thank you very much for that. It was source of inspiration and source of improving my own code and reproducibility of my own configuration. So yeah, but challenges. So I think like one challenge is tracking every modification. So for example, I have this situation that sometimes I want to try something, but I'm not sure if I will need that. So automating that at this point doesn't make sense. Yeah. So the question is how you deal with that.
I think for me it's not a matter of choice. I always choose to automate, because later on, like 6 months later, when you change your system, you're gonna forget. You're gonna have to find your nodes, and I prefer to document my nodes in code so I can just apply them. But it also depends. For example, when you cannot find a good way to code something that's like, for example, through a GUI, then there's no way. Then you have to do manually. But yeah.
What about experimentation? Like if you want just like check something, what you do?
Check something like what?
Like a new tool which you don't know that you will have to install in future. Maybe you will check and you will decide, no, this is not it.
A new tool should be installed in a cube, for example?
Yes, yes.
I normally start at disposable VMs, and if I have the code easily to be done, like for example, I copy previous formulas that I have, and I modify some things, and then I just target the disposable.
Okay.
So I don't have to worry about deleting the cube after.
Okay, makes sense. How you deal with the DNS resolution, like when you want to firewall stuff? Because in Qubes, DNS resolution is like one thing, and there are many players who use. So, for example, I want to separate Spotify. I use Spotify, and yeah, but they use heavily CDN, and this is problem. Yeah.
I don't deal with DNS on Qubes. It's difficult because NF tables is IP based. I don't have an example right now, but it's on my files. Like for example, the development cube that I have, it has no NetVM, and it has a proxy to connect to Sysnet or Sysfirewall, for example, to have networking through SSH. So it's just an open port that's only available to github.com. So I can use the github.com DNS domain. But for example, for Spotify or Signal, which they use CDNs, I believe both, I don't have a solution right now. And there's other community options that I saw, such as DNS script, that you can limit based on the domain name. But I haven't tried them yet.
Okay. Yeah, what do you think? Like, is there any potential for the like this? If there will be this Qubes Air stuff with ability to remotely doing stuff, like what kind of potential you see with this? Is like could I, for example, manage all my fleet of devices, or like I don't know, maybe help others deploy things in a reasonably secure way?
I can imagine that. I'm eager to see the Qubes Air talk. Like, for example, if you have connection to the cube and you can execute commands on it through root, and you don't need the salt connector because maybe it can be in the proxy, and the proxy of the QXI connector, you can do remote salt on that. So I believe it is going to be a good way to apply state to multiple cubes that are not in front of you, and maybe a VPS, for example.
for some time I already have this idea of simplifying life for Qubes OS users in a way that, so for example, you have some workloads, anyone has some workload. Right now the workloads defined by Qubes team are like very kind of specific on the one side, but on the other side you can choose a lot. There's too much to choose, yeah, to be honest, and a lot you have to do yourself. But if you could have this kind of workloads defined in those SALT, the question is if this would make sense for Qubes to have this to just enable, like what, I don't know, I want signal, and I will correctly define signal VM, separated and so on and so on. Does it make sense to have in Qubes included that, or this always will be community part? You don't know.
I have a thought about, because I'm community, I'm not in the Qubes team. I understand why Qubes doesn't do it, because they don't have time.
Yeah.
Like there are many formulas available for some years, and even to review one state or two states, it takes time of them. So like maybe it will remain as community project. Maybe some things can be included on what they want to have basis instead of me proposing, because like I would like everything that I did. So yeah, maybe what they want I can try to emerge upstream.
I'm already thinking about the market, yeah, because
we have this config repository where we have a bit relaxed policy what we can put there.
okay, so the problem is on auditing all that stuff, yeah.
Yeah, but we have like it's about trusting the author, so you install package only from the author you trust. So yeah, we don't provide any guarantee what's in this code. Besides that, we keep the integrity of the repository itself only.
Understood.
So, yeah.
Okay. Okay. Thank you very much. Great talk.
Thank you.
There is one question from
To the mic, please.
can somebody read, because my power cable is not long enough.
Yeah, I'm just going to my Matrix channel.
Okay, so the question from Magic is, where can you find guides for styling Jan and Jinja? You also talked about using salt linters. Can you expand a bit on that, please?
Where can I find guys for what?
Guides for YAML and Jinja.
Styling
YAML
and Jinja.
Guides for styling. I think on the internet yeah, really I don't have anything in mind, but for linters there's salt lint, there's YAML lint, there's PyLint when you use Python code, and try to find linters for everything you can so you avoid common mistakes. Yeah.
Hi there, I'm Corey with
Hi.
the Freedom of the Press Foundation. Thanks for your
Okay.
talk, Ben. The discussion that you've given on provisioning all these different kinds of resources and Peter's question about high-yield experimentation prompts me to ask, how do you deal with deleting things that have been configured this way? If you just remove them from the top file, Salt stops managing them, but the resources themselves don't go away.
Mm-hmm. I don't delete them.
Just
if it is there and
Yeah.
if I need to delete a cube, maybe I use qvm remove.
Mhm.
There's like a state module for that where I can remove a full cube. But if I have, for example, modifications in DOM0, then you have to use the correct tools for itself. Just for example, file absent,
Mhm.
that is the state module to delete a file. Things like that.
Great, thanks.
Last question.
Hi. I was just wondering, is there a possibility to do like finer configs on the cubes, like installing a Flatpak or something like that, or executing commands, or is it mostly just provisioning these cubes with packages that are to be installed?
You can through the command run, for example, execute any shell command.
Mhm.
So you can do that. I just didn't show any examples because that in one sense is like the prohibited salt module because it's not independent.
Mm.
But you could do any command. So just for example, run Flatpak. Yeah. Okay.
Okay. Yes. Thank you.
Thank you. Thank you.
today I present you FlashKeeper, where SPI Spy meets stateless laptop jaded dreams. Our retrofit plan first. So the plan of today, I would just go point by point like it's going to refresh at every slide. So I would start by who I am. I'm Thierry Lorion. I started AnswerGo in 2017, I think. I did the Privacy Beast at first to bring back like used computers, core boot and everything inside of Qubes OS. I was certified. I sold the laptop until 2019. Most of my work is granted funded work by NLNet. This project, FlashKeeper, is also funded, was recently funded. Yeah, and I'm the heads maintainer. That's what I do. Everything that I do is to facilitate accessibility to security and confidentiality. So my goal here is to always try to make things like easier for everybody. And your feedback is really important on everything that I do. So please contact me on GitHub. I'm not alone here. The main brain of this project is actually Dodoid. He will be present at the end of the talk. He's the mechanical engineer that decided to participate in this crazy dream of mine of this project. Why this talk? A big disclaimer. Normally, I tend to talk of the things after I release them, after I finish the project. This is the first time that I talk about it like once it's just an idea. So the goal of this talk is to get your input. So I will try to go really quick, but I have a tendency of talking a bit too much. So I will try to not talk too much this time. Why x86 situation is problematic. The problem that we have today is that the root of trust inside of core boot is basically inside of the boot block. The only alternative that is pushed forward since for a really long time is BootGuard, but BootGuard is also problematic. All the other projects that try to make this thing like easier is depending on write protection security features that are normally dependent as well on SPI chips. So even yesterday I talked to Nova Custom, and they said that even in the same batch of laptops that are being delivered to them, the SPI chips are different. So we cannot really rely on chips that are supposedly present in our laptops to always be the same. So that's that. 3M Dev here already made an amazing work on past grant work as well to support part region. Anyway, we said it like part region write protection, meaning that you can decide like to try to protect just the boot block, but it will overlap a bit. And then even if you just protect the boot block, it means that if core boot decides to change the boot block, then if you try to write to that region that is write protected and it's a little bit like larger, or if anything changes there, then you're kind of locked out of your own laptop. That and the fact that each time that you try to apply the region protection, you also need to solder the pins so that the protection is actually activated. So it's really not perfect. So you have like to solder write protection to ground, and that's not good. So the only solution that is really there right now is BootGuard, and BootGuard, as we know, is fused with keys like inside of the CPU, meaning that for the lifetime of your laptop, once the key is fused, it's one-time programmable fuse, so it's OTP. You cannot decide to flash your own firmware anymore. You're kind of stuck with the OEM providing you the firmware forever. And we also know that BootGuard keys have leaked before. The MSI situation is there to prove it. The keys were leaked 1.5 years ago, and there were no recall whatsoever. Nothing punished them for their bad behaviors. Intel didn't do anything about that. You can actually download the private keys yourself, and we could decide today to do a new firmware image for MSI. Anyway, that's just to prove my point. So basically right now we are living in a plug and pray situation with the computers that we try to trust. And the question here is like, what can we do as open source software to try to challenge that? And this project is an attempt to that. as a retrofit. I'm not talking about like new designs. Why FlashKeeper? Like I said, it's a retrofit design. So what we try to do is to sit on top of already existing solutions. So this works also for your laptop, desktop, server, TV, remote, embedded project that you have, any personal project that you try to attempt as well. The goal of this is has multiple goals, actually. It's to permit like core boot developers to quickly flash their projects, to implement write protection as a software dumper so that you can actually decide that you write protect your state right now, and I will talk about like the details later. But the most important part is for introspection of what is happening from the PCH. So how the computer, the host, is actually reading the firmware, how, when, talk to attacks and everything, and being able to do a boot stream validation, which is a coin term here. The goal at the end of the project would be to be able to check some parts of the flash region. So we're far ahead. Like I said, it's an ID. We don't know how it will go, like the project is scope and everything, but like the end goal would be, for example, to say really early by singing, like the speaker modem inside of core boot, like this thing that can actually sing you a song, but being able to say, okay, but the boot block is compromised, like it's not the signature that we expect, so sing really early to say that the computer is not in the state that you expect. So what we want at the end of this is temper prevention, but also temper evidence. Like everything inside of EDS you already know, most probably, is about temper evidence. But here we try to push it further in the sense that if something change, we want it to be able to be blocked, but we want something that will interact with the user out of band. So something that will say to you, don't type your passphrase right now because your computer is not in the state that you signed, so in the state that you decided that was trustable. No lockdown, and like I said, it would be applicable to a lot of other projects. So the goal here is to apply this to everything that already existed. And Joanna Rutowska, her last talk, I think, was in 2015, and she pushed the dream of like a stateless computer. And I think this project would be the first step so that we can convince manufacturer to do something different for the future. So what will be FlashKeeper? Like the high level is this. I will read with you, but like FlashKeeper is a device that can permanently be installed on common flash chips. It attached to the chip either by being soldered or with a peel and stick layer with spring-loaded contacts, interfacing with the SPI chip pins for easy OS and SPI introspection, write protection, and external reprogramming. This is the really big draft of how it would be for the solderless version. The idea there is to have like spring-loaded contacts with what we will develop as being like a FPGA MCU on top of that. And the idea would be that to be epoxied or resin so that the people wanting to have like temper protection, all of this would be glued under something, And after that, the interface, the cable would be outside so that we can reprogram and everything, and being able to provide keys that are user ownable and transfer of ownership. I will go back to that a little bit later. So that's it. Is the introspection. So the three goal there, I think I'm repeating myself, but like introspection, write protection, and easy external programming, internal programming. The goal here, and we don't know exactly how it will go there, is, as I said, since we don't have the control of what SPI chips security features are there, we don't know if we can actually apply the right protection of the chips that are already in the laptop. So I think that the way that we will go forward will be probably to have an SPI chip inside of the FPGA that we will use, that we know that the right protection can be enforced, and then software flip the bits to have the right protection in place. Here it's a really long thing to say that basically allowing authentication for external programming with write protection control, independently verifying the SPI flash image boot stream against a user-controlled detached signature, at each boot prior of the platform owner to enter any secret. So the building blocks. SPI Spy, I don't know who here already knows that project. 1%, 2%. That was a project for kind of my mentor, like Tramel Hudson, developed that. The goal of that was to be able to facilitate the reprogramming. The firmware is running completely in memory inside of the FPGA. And then you connect this with a normal clip on your SPI chip. So the computer is actually booting something that is in memory inside of your FPGA. So that permits you like to iteratively and really fastly flash device, because you're not actually flashing. You're saying, I want this firmware to run. It runs from memory. And this project was really, really nice for security research and purposes, because you can actually have a tracing of what is read, when, in which order, and use that to discover a lot of TOC2 attack, which means like something that is actually read before of execution, so there is change. So what you see here is like the moment of read and the moment of execution is not at the same time. So a lot of attacks were discovered with this project. We will use it as a base so that we can actually see what are the timings, being able to iterate in development so that we can have a base, which is the FPGA that we want to base the research on, to create a really small factor. You know, like the SPI Spy is like a big board that will be outside. It will depend on either the solder-less or solder adapter that will be inside of the motherboard. So that's the base of the development. With that, we will be able to say, like, answer a really important question for us, because we want to know if we have enough time for the FPGA to boot itself from the boot stream. And if we're able to do that, it means that the boot stream will be able to execute just enough, like, enough boot to be able, like, to sign and verify what is inside of the SPI flash of the FPGA. And if we can do that, it means that we will have something that can be upgradable on the FPGA, and that's the goal. Because if we can do that, it means that a lot of collaboration will be possible on that project, meaning that you will be able to sign what will be your firmware, and then you can iterate the development on the features that you want inside of the FlashKeeper. But it's still going to be validated. And one of the goals that we try to push inside of this project is to go against what BootGuard is doing right now, which is like one signature fused one time, and then you cannot transfer ownership. So what we're trying to do here is that the first owner will always be in control for the second owner, and then there's a transfer of ownership of the key. So if today I decide to give my laptop to Peter, I would have liked to actually sign his key, and then he's going to be in control of the firmware updates that are going to happen inside of FlashKeeper. Then we will need a logic analyzer to be able to see what are exactly the delays that we have to deal with, because everything SPI is really, really time critical. For example, if your image is not ready at the moment that you power up your machine, the laptop just doesn't boot because there's nothing to boot from. So we need to have everything ready. There's time consideration for power up and everything that we need to figure out. So this is a reminder of an old dream that Qubes OS had. This is coming from 2017 post saying that 2 years later we would have like a level 2 stateless laptop, which never happened. I don't know the story there. I would love to know a little bit more, because like this is stating that there were partners that were going to do something about this. This kind of never happened. It says that in the immediate future, therefore, we intend to pursue a level 1 laptop. We can foresee multiple levels of compatibility. I don't think I have the quote here. Anyway, the point is there was supposed to be a stateless laptop, but it never happened.
However, we expect that it will be at least 2 years. At least 2 years.
At least 2 years, but I don't have it.
A true stateless laptop can be created.
Can be created doesn't mean it will be created.
No, it could be. Yeah.
Just a speculation that it will be possible.
So if we read the paper of Joanna, basically her goal was to centralize the state. She was including also like the firmware of the SSD drive inside of this compounded like firmware, externalizing the state into something that she called the USB secure disk stick, and make states read-only. How? She was repurposing multiplexing USB pins, which doesn't seem possible. The plan was not a retrofit, but like a plan to actually convince OEM to be able to create that hardware out of thin air, like without any guarantee. She was planning into doing like read-only region, which were measurable, temper evidence, and what she envisioned was an SPI chip and FPGA inside of a chip to go into the direction of doing a stateless computer. What we have now is flash ROM with partial write protected region, like I said earlier. This is the step that happens like on a logical level, let's say, like on chips that are permitting write protection. And this is something that is available inside of 3M Dev Shop right now. So basically this is simulating the soldering, like it's just a jumper. On the hardware that we have today, like a lot of people go on GitHub and say that they are interested in this kind of protection to the moment that they realize that it implies like soldering and unsoldering, and people just give up on that dream. So a lot of interest to the moment like of realizing that it's not really practical and nobody actually want that. They dream of it, but they give up. So the step plan is the solder design. We can actually imagine just something like that. The idea would be like the FPGA and like the contact, like the FlashKeeper base would be soldered and something like that. The solderless design, we showed like the picture, like with the springs and everything. The idea here is a peel and stick plus mechanical design. So with some kind of guider, with a 3D printed thing, you would just like apply this like directly on your chip. It will guide like at the moment, at the good place to be able to just like push. And the glue with the device, with the chip, will make it like permanent, like forever. For that to happen and be successful, we will need to pass like drop and vibration tests, because like if it's not reliable, it means that at some point you lose the connection and then your laptop boots nothing. So that's kind of important. And the note here is that it would not be recommended for temper resistance, because there's no way you want something that is not soldered but with epoxy on top of it. Because if for some reason there is oxidation, or I don't know, the liquid of your resin is actually getting between the legs of the SPI chip, then you lose your laptop, and then you go with a hammer, and like that would not be a good plan. So even though we sold this idea to NLNet as being like a solderless design, the more and more we think about that, the more we realize that soldering will be most probably needed. I skipped a point for the solder design, but the solder design comes with a guider as well. We want this to be hot hair soldering, so that it's easy for OEM to be able to deploy this kind of setup, like without too much complexity. So the dream with that would be to have something that is as easy as a video to follow, and then you receive your kit, you put your 3D guider, you apply hot air on it, and it's gonna stay like forever. So the FPGA-based verification and flash management, we will need a bigger board. The goal will be to debug and develop. That's mostly the DOID that will be in the call later. To do the write protection and reprogramming. At this stage, the user configured keys will be provided over the external SPA interface before flashing. Development of external USB programmer board for reprogramming and debugging FlashKeeper over external flash cable. So everything is mostly going to be outside at this point. And this base will be used to do the smaller FlashKeeper version, which goal is to be inside of the laptop or the device at the end of the project. How to secure the FPGA state. So now we introduce a new thing inside of the machine, which is supposed to secure the state. So how do we make sure that this thing will be able to secure itself? The FPGA bit stream, that's a term like of FPGA, is the first part that is able like to boot something else. Like I introduced before, the idea there would be the bit stream being able to have just enough bootloader alongside the bit stream to verify externally loaded firmware. As I said before, if we arrive to this and the timings are good and the FPGA is able like to boot fast enough, it would mean that we have an externally upgradable firmware, meaning that collaboration will happen. We have a high hope of this to happen. If it happens, then it's a success. Otherwise, like we don't know what we will do. Like it's a really important point. The goal is the bootloader provided signature verification of the loaded FPGA firmware against a provided user singing key built into the FPGA bit stream during the initial programming, and then the support for user authentication reownership, allowing a chain of replacement singing keys back to the prior owner and the key, the original key that is inside of OTP. And the real-time boot stream verification, this is where I am really interested. The goal here, if everything goes well, once again, is not only to have a boot stream verification, which is like just checksumming everything operation that happens like in a stream, but being able to have introspection enough to say, okay, so here we have IFD, we are able to jump fast enough to say, here is the boot block, like, and then being able to just hash specific section. If we're able to do that, we will be able to warn way earlier than waiting for all the boot stream, sorry, to be happening before being able to warn the user. So we kind of need to have like specific region, otherwise we will warn later. Exception maps are also expected. For example, the Raminit MRC cache might change. Sometimes there is bad implementation. If I think about the KGB 16, for example, like it reinitialized like the cache. Anyway, I've seen like wrong things happening there. So there are regions that we won't want to check because they might change. And I think about like configuration and anyway. So the mind game here is like to think everything forward, but the plan is made in such a way that we will be able to see things happen, hopefully. So, and the goal of all of this is being able to happen between 5 and 30 seconds so that the user waits for a beep before typing any secret. So basically this. Questions?
Start the Jitsi here.
Oh.
Rafał, ściszysz te dwa mikrofony?
Yes, so I think you're on the speaker. It's gonna be easier.
Oh. Kitty, I believe you're muted. You may want to unmute yourself.
Now it's okay. You have to speak only to this microphone. Not on mute. Do not unmute there.
Yes, I'm probably from the mic.
Okay, I think I can hear you a little bit now. I just muted my YouTube tab.
Test? Test, test? Okay.
Yes.
Yes.
Okay. A bit of it. Just don't talk too loud.
Okay.
I can do that instead.
Okay, I have. Oh.
Let's try. Oh,
Okay.
I can hear you now.
Okay, I have two questions. One is how you ensure that when you boot with this FlashKeeper that you actually, as the user, have legitimate the original FlashKeeper confirming the firmware and not something like planted by attacker. And the other question, if you consider soldering, why not simply replace the SPI flash with the one you do know that have working write protection? So that's. How the user can verify that it still has the original FlashKeeper and not something with, for example, replaced bitstream or something completely different.
A firmware has not been tampered with because there is a one-time programmable firmware in the FPGA that before it will load any other firmware is going to check it against a key that the user holds and ideally is protecting. Does that answer your first question?
And users still need to somehow protect against like physically replacing the FPGA with a new one, like glitter on the screws or something.
That is correct, but it's not screwed on. It would be adhesived on. Now there's attacks that you can always make to anything physical. And Thierry was talking, for example, about epoxying over the chip, which is something that I know a lot of people already do, even without any sort of active component embedded in there, just to try to guard access to the SPI pins themselves. The ideal future would be where he was talking about SPK modem. The ideal eventual outcome for this would be that by some external means, the FPGA would be able to authenticate itself to you in such a way that if it were replaced, the replacement not holding your keys would not be able to authenticate via the sort of SPK modem style thing T-Lorian was talking about. That is admittedly further than most of what we're pretty confident about right now, but that is something we've thought about, and it's worth noting that in the typical way we see this being installed, it's not as simple as take some screws out and change a board if an attacker was going to try to replace the whole module. Your second question, I'm sorry, you were asking about the... What was your second question again?
Why not replace also the SPI flash with something with non-working write protection?
So the point of the FlashKeeper FPGA is that you don't need to rely on the SPI flash chip's write protection. I think something that should be clear, something that I should make clear, is that we're talking about multiple stages of development on a project here. The first one that Tilorian brought up was the piece that I refer to as the chip adapter, which is the actual thing that sits on top of the chip. That can be either soldered or solderless, and it can hold the write protect pin of the chip. So with the chip adapter, yes, you are relying on the flash chip's write protect. When you are installing an FPGA on top of the chip, that's when you're looking at what he calls introspection, what I would say authentication of the boot stream, where you're actually looking at what is being read out of the flash chip every boot, and you're hashing that to see if that matches a signature the FPGA is holding on to. In that case, you don't need to worry about whether the chip itself is enforcing write protection, because even if the attacker did write to it, then once the FPGA is there and it's doing that authentication, it's just going to fail the signature check at boot and alert the user. As for if you're going to solder, why not remove the As for if you're going to solder, why not remove the flash chip? The soldering, to me, like, I do this all day. Yeah, to me that sounds reasonable. Just pull it off and wire whatever you want. To somebody who is not familiar with doing surface mount soldering all day, desoldering a surface mount chip and replacing it with something is a bit of a bigger ask than sticking a thing on top that has some pre-applied blobs of solder paste on its pads and heating it up with a hot air gun. So even when we're talking about the soldered version, we're not talking about the user's going to pull this chip off, clean the pads with wick, make sure they don't rip any traces, and then solder a little module on in place of it. We're talking about the user's going to stick something to the top and blow a hot air gun on it. And we don't actually really need to remove the flash chip itself, because even if we were to imagine a version of this that doesn't rely on the flash chip at all, as SPI SPY has demonstrated, because of the series resistors that manufacturers almost always put on their SPI data lines, you can pretty much just talk over the SPI flash chip without doing any damage, and it's probably easier to just let the user leave it on there and put whatever you want on top. Does that answer your question well?
Okay, thanks.
And it sounded like as text, Demi had a question. Okay, so she's asking about, for reownership, how will you ensure that the old key cannot be reused? We want to research whether it is possible to update something in NVCM, like to set an additional bit of NVCM after it is initially programmed on the ICE40. If so, we could have effectively a unary counter where we would say that, you know, we should be at key number whatever, and the key that's burned into NVCM already is key number this, so we're not going to accept these earlier keys. If that is not possible, unfortunately, that the very original owner would be able to reuse their key to sign future keys. Keys further down the chain would not be. If that is how it ends up being, yes, of course, that is a limitation of how reownership would be able to work on this. And if you were truly concerned about the original owner's keys, you would need to get a new FPGA and burn the NVCM yourself rather than buying a used one. Unfortunately, while the ICE40 is very documented, we're not sure whether it will be possible to burn over existing NVCM yet. That's not something I've found good documentation of, and it's probably just going to take some experimentation and probably effectively killing some FPGAs in the process, because it is a one-time programmability thing. So if that's possible, then yes, you can do like you typically would with one-time programmable memory, where you increment the unary counter and the old key is no longer valid. If that is not possible, then the original key will not be able to be truly removed. And in that case, the reownership, if you're concerned about that, you really should be going for a new FPGA, which won't be tremendously expensive. So unless this is a matter of somebody has some super valuable laptop motherboard and it's been epoxied on, it's not the end of the world to replace the FPGA if you really are concerned about that. Where will you store the persistent data? You're asking. Okay, I'm just trying to answer Demi's questions. She says, where will you store the persistent data? Outside, so on the FlashKeeper FPGA. Oh, okay. I leave that call to you. Demi's asking questions in the text chat, but if you'd rather answer questions in person, we can do that too. Just quickly for you, Demi, it's planned that the FPGA module would have its own, like, very small chip scale package, second SPI flash on it. Of course, the contents of that would be authenticated by the FPGA itself. So you don't need to reserve any of the host SPI flash, because the FPGA module, even though the FPGA chip doesn't, will have a little bit of flash of its own.
Microcontroller and multiplexing to a real SPI flash, so you don't have to meet the hard timing requirement for SPI in the FPGA?
We did. The problem is not that you need to emulate the SPI flash. The way we're actually imagining the FPGA variant to work, we are not emulating the SPI flash. We are authenticating communication with the stock SPI flash chip. The reason we are unlikely to be able to get away with a microcontroller rather than an FPGA is that, for one, FPGAs provide a lot of flexibility around things like one-time programmable NVCM and things that we want for security. For two, when we're looking at things like real-time authentication of the stream going over the SPI bus, you want an FPGA because you can do things like a Blake2 hash in real time and like really tight timing, high throughput real-time verification, where you're not needing to build a full copy of the flash in memory and then come back and hash it with a CPU later. That allows you to really cut the amount of RAM that you need to have on there, which is important for this.
Yeah, I was thinking of verifying this reboot, so cutting down on your requirements. Obviously,
well, the problem is you need to verify it. You need to verify what the PCH actually sees, because the PCH is communicating with the SPI flash chip. If you verify truly pre-boot, like you just have a thing that's sitting on there and it listens to, like, it talks to the SPI flash chip, checks what's in there, and then the machine boots, then you have a talk to vulnerability. Because imagine a glitchy, malicious, anything SPI flash chip, or even something somewhere else on the SPI bus, could provide a genuine image to FlashKeeper and a malicious image to the host when it boots. So you can't.
Little trust into your SPI flash. That answers my question.
Sorry, I don't fully understand. What are you saying?
Yeah, next guy here. So part of my question was already answered in the first question. But how far along are you in the development of the variant having the FPGA chip?
Done some tests, nothing talking to an actual SPI flash chip yet. As Telorian said, this project is early stages. I'm glad that he's presenting it early, but I expect that the next time we talk about this, we'll have a heck of a lot more to show for it. We've experimented with some of the parts of this that will be necessary, but like the chip adapter designs are moving. The FPGA stuff, I want to be honest with you, we do not have it authenticating an image on a real SPI flash chip yet. The project just hasn't been going long enough for that to be the case yet.
And just something for consideration, since you're expecting to be using hot air anyway, have you considered using lower temperature hot air solder mixtures instead of just glue or resin or whatever?
Yes, we have. We've considered low temperature solders, and it's definitely something we're going to play with. There can be metallurgical constraints in using different solder alloys together long term, but it's definitely something we want to look into, because especially if users are afraid that they're going to cook their board or whatever if they're too slow with it, low temperature solders are something we've talked about. And if it's something that comes pre-applied, that's something we can do. Any further questions?
Thank you.
All right.
Hello everybody, welcome to my presentation about Anti-evil-maid, the status and future plans for Qubes OS development of this feature. For those who don't know me, I'm Michał Żygowski. I work as a firmware engineer at FreeMDep. I'm a firmware guy doing core boot. I maintain certain parts of the project, certain mainboards which are listed here. I'm engaged in open source firmware since 2017 when I joined FreeMDep. And yeah, I'm mainly interested in enabling various advanced hardware features in the processors. And I also occasionally develop trench boot. So I recommend to watch my previous presentations and my colleagues' presentation from the last summit about the Anti-evil-maid. We have been also talking about the progress, what the project is, what is working, what is not, what hardware we use, etc., and the plans we had back then. So what in short the Anti-evil-maid is? It's basically a set of software components and scripts developed by Qubes OS team and gathered under the Qubes Anti-evil-maid repository. The goal of this feature is mainly to protect against evil-maid attacks. So if you imagine staying in a hotel, for example, you leave your laptop in your room and you're absent. A room service comes in, sees your laptop, and a nasty idea in a maid came to her mind, and she or he decides to install some kind of keylogger into your bootloader, or it something that injects something malicious into your operating system components. And then she came back some time later for room service again and reads out the secret information you typed in. And then she suddenly becomes an owner of your device. So basically this set of packages and scripts is aimed to prevent such attacks or at least detect them. So typically when everything is configured well, this is the screen you will see normally when booting Qubes OS with Anti-evil-maid enabled. So what we actually need to get the Anti-evil-maid working. So there are two main things that your system device needs to support and basically have. First one is the TPM, which stands for the Trusted Platform Module. It is a specialized chip that aids various cryptographic functions in the system. It can store measurements and hash of the components that were, for example, executed during the boot process of a device. It doesn't has to be limited to firmware components. It also has to may hold measurements of the OS operating system components you have launched. Typically, it is available on almost any device nowadays, usually in a form of a firmware TPM, which is integrated into the chipset or CPU. However, there are some cases where even if TPM is available, it won't work with the Anti-evil-maid because AMD FTPMs are buggy or at least have limited functionality, which will not allow us to use the second feature which we need for the Anti-evil-maid to work, which is the DRTM. So DRTM is a dynamic root of trust for measurement, which is like a kind of silicon vendor technology that allows you to re-establish the trust in your system in a secure manner. So this basically adds an extension to the typical instruction set of the x86 CPU and possibly other CPUs in the future, which allows you to securely measure the components at a given point of time. So what we use it for is to measure these operating system components independently from the firmware, right? And yes, it needs to be, this capability of this dynamic launch needs to be present in the processor and sometimes chipset in order to actually make an use of it. The main noticeable difference in the TPM measurements is the availability of the measurements in PCR 17 and 18. For example, in the case of Trendwood, which is like a separate set of measurements that are only unlocked when you have actually performed the dynamic launch. But how to deliver the DRTM to our system components? That is where Trendwood comes with the help. So Trendwood is, let's say, it's a framework that integrates into our operating system components to deliver us the security engines and mechanisms to actually perform this dynamic launch. And currently, our Anti-evil-maid efforts are basically focused on integrating Trendwood into Qubes OS system components. So a little bit about the status of this integration compared to the past year. So we managed to finish two phases of the whole project, which is update to the newest Trendwood boot protocol, because we are still not yet finalized the interface and the methodology of performing the dynamic launch for the open source software components like Linux and Zen. It has the boot protocol tends to slightly or more significantly change. So this phase focused on getting everything rebased on the newest code base and then retesting everything what we have developed so far. And second milestone we have finished was the already mentioned by Marek AMD support for the Anti-evil-maid in Qubes OS. So this is something new that wasn't present in the initial Anti-evil-maid implementation. If you look back at the very first sources, it was only available for a certain set of Intel hardware with TPM 1.2. So today we are in the state where we can use even AMD machines with TPM 2.0 to perform the dynamic launch and actually leverage the anti-evil-maid feature. Yes. So a little bit more about the updates we also did besides the planned features I just presented. So last year my colleague did a little bit of discussion that Qubes is not so friendly to freshmen, right? Also Marta was saying that copying to DOM0 is dangerous, you don't want that, but on the other hand, you sometimes need to do so, and it is hard, right? So we try to simplify things. In order to actually get this anti-evil-maid working with Trendroot, you have to install the custom components because we are still in the process of reviewing and merging possibly the patches into the Qubes components. So in order to deploy everything smoothly, we have prepared the building of the packages in the continuous integration, and we have set up even an anti-evil-maid testing repository that holds these components and can be installed in a very simple manner, like you would install any Qubes packages in DOM0. You just simply add a definition of a new repository and pass it to be enabled to do Qubes DOM0 update command. Of course, the downsides of this repository is that we are still basing on Qubes release 4.2. So yes, the rebase onto the newest components like Zen and Graph are still on the roadmap. Yes, okay, so we have all these things working. We have like Intel hardware supported, AMD hardware supported with TPM 1.2, TPM 2.0. So what else do we want? Well, if we look back at the Trendroot testing, one could see that we mainly tested it in some random hardware that was pretty much cheap and quite available, but these machines were running typically some proprietary firmware. Yes, the reason behind these decisions is that hardware that is actually dynamic root of trust for measurement capable is pretty much hard to find. You cannot find these capabilities on some lower end devices, processors, right? Secondly, you need a proper firmware support in some cases to get the RTM working. So as a preparatory step for getting it working on open source firmware, I have presented a demonstration of running this Trendroot anti-evil-maid on the Dashar open source firmware supported Protectly network appliance device. It was on Zen Summit this year. If somebody was there with me, then they probably saw. However, there are still some downsides to using Protectly devices. First of all, they are good for development and testing because they have the serial port, which simplifies the debugging. But like I said, it is more like a network appliance. The anti-evil-maid is rather for devices that are portable. So in my opinion, the anti-evil-maid shines the best when it is like installed on a laptop, right? So the goal I have set for myself is to get the anti-evil-maid working on a Qubes certified laptop. And of course with open source firmware. So my choice for the nearest future was the certified Nova Custom NV40 series laptop, which is based on a 12th generation Intel Core processors. So it is relatively modern, right? Because these processors were like released maybe 3 years ago, right? It is already Qubes certified, so it passes my main requirement. It is open source firmware supported, so we release firmware updates via the Sharo. And of course, it is thankfully DRTM capable. Intel did a small, how to say, a small favor for us and enabled the DRTM capability on a wider range of their processors since this generation. So it is like a, I think, big step forward to have a wider selection of hardware that we can test it on. Of course, there are problems with these devices as well, because despite they are relatively modern, they are already not in production anymore. So Nova Custom is already running out of stock of these devices, so even if we release something, it will be very limited edition stuff. And another, I would say, disadvantage I have found is that you cannot enable the DRTM capability without actually configuring bootguard, or at least that's what I'm. That's what I think for now, because I haven't found a way to actually get it working without it. Because the TXT need to take some information from the bootguard structures, what is supposed to be measured and how it is supposed to be configured. So yes, and this is since the 11th generation of the processors. So another change, another problem. So what I have basically reached, I have used the CBIOS firmware because we do not support UEFI yet. So I have tried to show to the end users whether their system is actually DRTM capable and whether they have configured the anti-evil-maid properly. So what I did, I extended the Qubes OS global configuration page and the security report for additional variants that you can see on the screen. The two bottom features that are listed is the DRTM capable property and the anti-evil-maid status, which shows you whether the service running on Qubes OS has been properly executed. So the whole DRTM flow succeeded and we have everything set up correctly. There's also a small blooper here because the certified laptop is only for UEFI flavor of firmware. But thankfully, all NV40 series with the Sharo firmware are actually certified. Whoops. Yeah. Yeah. And the vessel from our customers like asking me, hey, CBIOS is not certified. And so I say, really? Okay. Of course, there are some issues because why wouldn't there be any? As I mentioned, we do not have UEFI support yet for performing the dynamic launch and booting Zen in UEFI mode. So as a result, we miss many of the setup features we typically offer with the Sharo. So like if you would like to disable the USB stack in the firmware or disable camera, whatever else there is in the setup, I don't remember really now. Secondly, most of the Sharo releases, maybe if not all today, are basically the UEFI flavors of firmware. So this is the test the configuration we test. So basically, if I produce a build with CBIOS, then I have some kind of untested configuration and different issues may appear. Second issue is that whenever I use the dynamic launch actually, so try to leverage the anti-evil-maid, I end up in the state where certain VMs are not launching. For example, sysnet, sysfirewall, and sysUSB. So yes, as the state is for now, this defeats the purpose actually of using Qubes OS, because if I have no isolation, for what I enabled this security feature, right? So this is the major road blocker.
Perfect isolation.
Yes, perfect isolation. No isolation at all. Yes, my prediction is that certain cleanup after the dynamic launch is still missing in Zen, in our implementation of entrenchment. So I will have to look inside the T-boot and see what I have missed. And the third issue, Zen boots terribly slow. Like if I try to, since the selection of the anti-evil-maid entry in grab up to the password prompt of the LUX key or TPM storage root key, it takes, I don't know, 1 or 2 minutes. That's very, very terrible, I would say. And the reason is probably as above. Some cleanup may be missing because the whole slowdown is basically on the steps where we measure the DOM0 kernel and initial RAM disk. So it takes the most of the time. Okay, just to show that I do not saying empty words, time for some demo. So imagine you are in a hotel room and some evil maid is coming. So it's time to secure your system. Okay, so I have another laptop here with me. It's a development and testing laptop, which you can judge by sending out wires here. First, I will maybe boot without the anti-evil-maid, just to show you that the Qubes global config is showing that system is DRTM capable. Okay, let it boot, and then okay, and this is the typical boot flow when you where you type the LUX password, and then we are shortly in the login prompt for the user. Okay, now I'm start to wondering what I will do if this awkward silence will come up when this slow boot delay will just come up. I haven't thought about what to talk. All right. Okay, so let's open a terminal. Qubes OS, oh, no, just Qubes global config. Yes, so the information is mainly sourced from the Qubes HCL report, right? So first step was to extend this page, in the GUI page, about these new 2 fields. And secondly, extend the HCL report to extract the information. But the tricky part about these two, at least about this DRTM capable property, is that Zen lies to DOM0 about the DRTM compatibilities, because it cannot tell you that you support DRTM, of course. Secondly, the comments from the instruction set that are used to invoke the dynamic launch will cause you a virtual machine exit. So they cannot be executed in DOM0, of course. So I had to expose this information in the Zen debug log buffer. So basically, I just added a few print case in the Zen trace, and then I just parse XL demask in the report, and that's basically it. The AEM status is much simpler. I just query the systemd about the status of the anti-evil-maid unsealed service, and that's it. And as you can see, it sees that the service is maybe installed, but it's inactive or failed because I haven't booted yet the anti-evil-maid entry. Yes, and maybe I will show how the demask could look like. Yes, and this we can, maybe I will enlarge a bit so it will be more visible. No. Oh god, I have this German keyboard and I can't find the plus button.
Maybe view and just plus.
Yeah, I think it will be easier.
Zoom in.
Zoom in. Maybe once more. Yeah. And where was that again?
It was more to the top.
Yep.
Here.
Yep, here. So I have added 2 prints because, firstly, I can query the DRTM capability just by using CPU ID. But the tricky part on Intel platforms is that you also have to detect whether your chipset supports the DRTM capability because, if you have a laptop, then it's easy because it's one SoC. And either it supports or not. But if you have a desktop, then you have like 2 components, CPU and the chipset is separate, right? And you can have a DRTM capable CPU paired with a non-DRTM capable chipset. So I have to use this special DRTM command that queries the capabilities of the chipset. And then, of course, I have to do it in Zen because otherwise in DOM0 it would cause a VM exit. Yes, so I just parse this information in HCL report and that's how I get the DRTM capable property. Okay, time to boot the anti-evil-maid entry. So I have prepared a special anti-evil-maid boot device on an SD card with multi-factor authentication. So just plug it in, reboot, and now I should boot straight from the SD card. You will see that there will be a grab entry with anti-evil-maid. Of course, it is beneficial to have it on a separate device because you can take your SD with you and prevent the evil-maid from stealing your SD card or installing the bootloader, right?
Isn't this part of the slowdown?
Only up to the loading components, which you will see. It is slightly slower indeed compared to loading components from NVMe. As you can see, loading Linux takes a couple of seconds. Initial RAM disk also a couple of seconds. But the real day starts when the screen is cleared and the Zen starts booting.
And there is this enabling S-launch line.
Yes, this is the extra important line here that says, okay, I want the dynamic launch, so please enable it for me. And this changed the whole boot flow of the platform and Qubes. So this is where Zen already started because it cleared the screen. Now it probably measures those DOM0 components right now.
Can you see what is happening if you remove the console equals none parameter? Because we disable console output from Zen on the screen.
Yes, it would be possible, probably, but you wouldn't see what is measured and when because there are no prints, debug prints in this part of code. I just added them manually to see where I have these bottlenecks, right? But in general, you should see typical Zen bootlog here. Yeah, and I forgot to show you the PCRs from before the boot that they are all FFFFFF. So these PCRs are locked. So here they will be unlocked and the reset state is 000 in such case. And then they are extendable.
I guess we can use this time for one or more or 2 questions.
Yeah, feel free. You can just idle on the.
Okay, so this is Intel, and
unfortunately, yes.
Yes, you said you have some also AMD version working somewhere.
Yes.
Oh, and I ran out of time.
Okay, that was the question. You asked about the AMD. Okay.
Yeah, my question was how far it goes with AMD and if this sysnet not starting problem also affects AMD.
Just confirmed on Intel.
Okay.
Not sure whether it is on AMD possible. Yes. So this is the screen I have showed you on the initial slide on my presentation. So the difference here is you receive a .p code that you generated during the provisioning of the TPM and the whole anti-evil-maid feature. So basically I can now check with my authenticator whether this code is correct. So it should be 889742. Correct. So now I'm safe to type in the password because this .p code shows me that the state of the operating system components have not been tampered since my last boot. So there was no evil-maid and she didn't install anything to steal my secrets. So now we will encounter another delay because the systemd will wait for the sysnet, firewall, and sysUSB to be up, and the timeout is about 2 minutes until it gets to the login prompt, until it eventually gives up later, which will of course show.
Another chance for the
Yes, yes, please do, because.
yeah, please. Yeah, I have like maybe comment. So first of all, like you should not care that you didn't show the PCRs. Like who cares? We care only about the Qubes OS security report and those greens. Marks.
Yeah, green check mark.
This is the most important thing. Yes, like, who cares about the value of PCRs? Let's be honest. Okay. So, can you tell a little bit more about this, like Intel vendor lock-in from 11th Gen? Because like this is something new for me, and I should probably know that earlier.
Well, it is also new for me too, because I was like working on it for the past couple of days, last weekend and stuff. So basically what happened since 11th generation is that Intel decided to merge the bootguard and the Intel TXT, so the DRTM technology, with the firmware static root of trust technology. So it occurred to be so tightly coupled that you have to provision bootguard in order to enable TXT. So the whole provisioning and preparation configurations relies on the configuration of Intel Management Engine actually. So you have to provision the configuration of Intel Management Engine. Then when you build the BIOS, you have to create manifests which you describe what bootguard should do, what should measure. You should also describe how TXT should be configured and then sign those manifests. So that's the main difference compared to the let's say 10th generation and older, where you simply put the ACM and do the TXT initialization during the BIOS flow. So it is like a dramatic change, which like I don't necessarily like. But yeah, we will have to live.
Does it involve putting your key in CPU or any other like one-time programmable change?
For testing, no.
Okay.
You just need to configure a mean which involves injecting the key hash into its firmware region somewhere, which is used to validate the first manifest, and then the first manifest has another key hash to verify the second manifest, which actually holds the whole configuration and data that is supposed to be consumed by the microcode and all this boot ROMs and stuff. Okay, so let's go to the loved check marks. Oh, this time sysnet started actually. Wow.
It's not end of the demo. Like,
Yeah.
let's look at the green check
It happened to me once that it actually launched all the VMs, but it was like, I don't know, one case out of 20. Like,
Just because Marek is here.
or we did such a long, talking before actually typing those passwords. Maybe this was the case. I don't know. Yeah. And drums, please. Yeah. So, as promised, I wanted a.
See some Wi-Fi? Is it actually talking?
Yeah, click on the network manager icon.
Click on the
Yeah, available.
Available?
Yeah.
Yes, it works. Once it launches, it works. But if it doesn't launch, then of course the result is obvious.
Sometimes it doesn't launch, so that's the point.
That's the whole point.
That needs debugging. What worries me for this new generation, from my perspective, like from 3M Dev perspective, this essentially will complicate the procedure of delivering the anti-evil-maid on the devices, and will probably rise its price, because like that means like someone will have to spend way more time, and it will be more complex to manage, because in addition we have to deliver those manifests, those Intel boot guard manifests. Which
anyway, you have to deliver the proper firmware.
That's like I assume that it would be in the first place anyway, but yeah.
Yeah. So as you can see,
firmware configuration, I guess.
Yeah. As you can see, those PCRs have been populated according to expectations, because otherwise these 70 to 22 are typically all FF and they are locked, cannot be extended. So DRTM allows us to extend those and use them in our policies for unsealing secrets.
That's for those who don't believe the green marks.
Yes.
Which command did you use?
Cut.
It was just the TPM2 PCR read.
Thank you.
Yes, and the HCL report also is.
If I see correctly, we see this is the legit value because it matches the slides you showed before.
Ah, okay. Yeah, it was taken
Looks
from
the
this
same.
particular laptop. That's yes. But I don't know if the PCRs I showed on the slides were actually from this machine. It was taken from a blog post, so it probably will be different.
Okay.
I think. Because I have made some modifications to Zen because of this capability reporting. Okay, so let's go back to our slides. Right. Okay, so evil-maid had an successful attempt, so she's angry now, and let's go further. All right, so like I said, there are issues. I want to resolve them, first of all, because otherwise the system's unusable. Next, we would like to offer this Qubes OS certified device with the pre-configured anti-evil-maid, and of course the firmware supporting this feature. Thirdly, UEFI support. Yes, because every device now runs UEFI and there is no legacy boot support anymore on the newest devices. So this is also very major and wanted feature. And fourthly, it would be great to have on the newest line of Nova Custom laptops, which are also already certified according to Marek, which he mentioned it already in his presentations. But of course it is like another effort to get it working because Intel changed things a little bit again. Yeah, and of course I would be glad if you could support us. You can scan this code or just click the link to sign up for some tech preview for the NV40 series, and of course when the Meteor Lake devices will be available, possibly also for the newest series of the laptops. Yes, and questions. Yeah, I went right through all of them. Thank you.
We are in the cloud.
Okay, so we will give some update on Qubes Air. That is finally something is happening in this area. So what is it? It's the idea that we posted some high-level design 6 years ago. I will show some motivation. What is it? And show some of the design of some of the parts that we are working on now and what we are leaving out for later. So why? What is it? Basically, the current Qubes OS version is a system you put on one computer and you have several virtual machines that you can manage. Currently, we support only Zen as a hypervisor. There were some community attempts on supporting KVM. I think they're quite advanced from what I remember, but still, this is a single system with virtual machines. So the idea is to extend this for multiple physical systems. So we have a lot of nice integrations that you can, for example, copy files between VMs or keep your keys, SSH keys, GPG keys, FIDO keys in some other place and then use them in different VMs. So maybe. We could extend this idea of running different VMs on different cubes in different places beyond a single system. So we can, for example, have a separate system which we consider much more trusted and use it for storing keys. And don't worry that some speculative execution CPU bug will be used to steal our keys from the system. We are, I don't know, random executables downloaded from the internet. Yeah. So, or maybe just have some optimization, like you have some light and convenient laptop, but it's not very powerful. But also you have some big workstation with a lot of memory, a lot of storage, and you can use it for some data storage, data processing, but still use those capabilities on your convenient machine, convenient laptop. There are many use cases like this, and if we extend this idea a bit more, then this other system may not even be a Qubes OS system. We can extend it to also connect to other systems, like treat a Raspberry Pi as a single cube and connect it to it, or maybe connect to some cloud instance also as a cube. And we have QRexec policy that can control what those entities can do. So maybe you can, I don't know, upload your photos to some, I don't know, some cloud service, but keep your emails locally. For example, there are many options. And this is actually something that some subset of that very small part was actually implemented in the past. There was a project that used USB Armory for split GPG. So there was a QRexec tunneling to USB Armory, which is a small computer with Linux connected basically on a USB stick with ARM CPU, and there was in that version it provides the emulated network interface on the Linux the USB Armory side, and there was a tunneling of QRexec connection
from some VM according to the policy to sysUSB that connected over this emulated network to USB Armory and then performed the signing operation on the USB Armory. So yeah, some proof of concept like this existed. The project was a proof of concept lab showing capabilities of the USB Armory device. Yeah, but it was very nice, and it showed that this capability is something that people find useful. So what we decided to build now is focus on QRexec connection alone for now. So we have different systems. It can be two Qubes OS systems or Qubes OS and some ordinary Linux. We will focus on two Qubes OS systems for now. And we add enough support to make QRexec calls from a cube on one system to a cube to another system, and that's all for the base support. Maybe we will see. We will manage to add enough capabilities to also start disposable cubes on the other systems. This would be very useful, but it's more complicated than we currently plan. What is out of scope in this version? We are not doing any GUI support for now. So if it's only for some QRexec services that are just passing data back and forth, so you cannot. Well, you can start a graphical application on the other system, but its interface will be on this other system, not on your. It won't be like forwarded back to your system. And there is in this first version, all the provisioning is just registering individual cubes from one system to the other, and it needs to be done on both sides. We will try to provide some scripting for that, to do that like semi-automatically, but it still focuses on individual VMs on both systems, not like automatically synchronize all the state of the one Qubes machine to the other and stuff like that. This maybe will come later, but not in this iteration. Okay. So the current idea is to introduce new cube type, and I think Frederick can show.
Yeah, sure. So yes, following what Marek said, we are going to introduce new objects, and notably what we call the remote VM. So it will be simply a remote cube. If some of you already look at the base code of Qubes, inside the Python code, there is some class that defines the Qubes VM, this template VM, anything like that. So what we will call here a local cube is formally what is called a Qubes VM inside the code. So we need first, before going into this subject, to slightly adapt some piece of the current code of Qubes, and so we will try to stick to some terms that say that when we speak of a remote cube, it will be something, of course, elsewhere from your station, that your local cubes, and what we call local cube will be the standard cubes that you have already. So a remote cube will be some general term to say that we are going to make some RPC requests to some entity. So as Marek said, it could be some Qubes OS instance already, so it will be some other cubes on another machine, but it could be also some Raspberry Pi, KVM VM, and so on. And so basically, for example, we might implement some disposable VMs creation on a remote system. So if you think of the new builder, we use a lot of disposable VM to build stuff. And so that will be some very nice case of using some machines to have some intensive builds. from your local Qubes OS. So, assuming that you have a remote cube somewhere, we need to make some communication between your local Qubes OS and your remote Qubes OS, and then we will need to introduce another type of cube. So we had some kind of discussion with the community to say how we will call that, because the first idea was to say that we will need some proxy, but in Qubes OS there is already some proxy cubes that exist. So we converge to say that we will need some relay cube, so they will act as a proxy, in fact. So you will have two relay, one on your local machine and one on your remote machine, and this is this new type of cube that will forward the request that you will do on your local Qubes OS to your remote Qubes OS. They will go through these relays. We will show you some example. So. Yes, we just listed two types of RPC requests. For example, when we did the proof of concept with Simon 2 years ago, we implicitly defined two relay and two cubes, and we use SSH to say, okay, I want to make some QExec call. I will just use SSH to finally call the QExec on the remote host to make the call. So we will show you some example, I think, on the next picture. No.
Yeah, you have the graph on the next one.
Okay.
And then description here. You can switch back and forth.
Okay, I will switch on the description, yeah. So the idea is to make some communication between your local Qubes OS and your remote Qubes OS. So assuming that you have a local cube on your local Qubes OS, I will precisely insist on the terms just for you to see exactly about what we. Well, yeah. Oh, it works. So you have local cube. So it's normal. For example, your personal cube on your local Qubes OS machine. So imagine it's a laptop. You have also some cube on it, which is a local relay. And assuming you have another Qubes OS somewhere else, for example at home or somewhere, so it's called a remote Qubes OS. On it, you have a remote relay and a remote cube, so your destination cube on which you want to perform an action. So making a QExec call from local cube to remote cube, it will be a matter of several steps. I hope you can see the text on it. Is it fine? Okay. So first of all, you imagine you want to copy, so you will call the QVM copy RPC as if you will do as usual. You will be prompted to say, okay, what is my destination cube as usual? You will have in the list simply remote cube. Really as if you will do it as usual. So you will have some RPC process to check, are you authorized or not. So typically, have you accept or not the RPC, and then it's there where we need to now introduce more steps in the processing to simply transform the current QExec request into another request, if I can say so, using what I called before the transport RPC. So basically, when you QExec something, we will wrap into SSH, for example, that we will need to QExec call the final destination with some arguments and some service that we requested from the original cube to make it work. So we do the wrapping of the QExec call. We do the execution. So basically, for example, SSH, the destination execute QExec on this cube, and then the remote Qubes OS instance receive from the local relay. So it's a remote relay that will initiate finally the QExec call to say I want to execute the copy of the given file to the destination cube, which is remote cube, and then the remote Qubes OS check that you are allowed to QR exec from remote relay to remote cube, and then if you have the right to do so, you simply going back to the original cube. So through first the QR exec protocol, then the transport RPC method, so SSH network, the network stack, and then QR exec stack, and you are followed back to the original initiator. So the steps are basically this one. So the one I tried to explain. I hope it was clear. So this one, and so when we spoke about to have possibly just only physical machine or even VM that are not from Qubes, in that case we need to specialize a bit. So relay VM is at first a remote VM, so the more general remote class is a remote VM, then on which you can specialize this remote VM to be a relay VM. But in the case of, for example, just one non-Qubes machine, we won't define remote cube. If I take my previous example, there is no remote cube on a Raspberry Pi, for example. So, in fact, the Raspberry Pi will directly be the remote relay itself. Speaking of network connection, you will reach the Raspberry Pi, and in fact, you will reach the remote, what is called here a remote relay. I think we have some
there's a
diagram. Yeah. So it's simplified to that in fact for a physical machine or a standard VM and so on which you can reach it by using network. In that case, the relay and the remote Qubes OS host, of course, and the cube is itself the same entity registered in the local Qubes OS. So steps.
Steps? Maybe
No.
then the next one?
No, this one, sorry. Oops.
Yeah,
okay.
So that's.
So, as you can see, there will be a lot of issues to manage such thing, because here you need to. There is some issue with trust, notably when one imagine your remote Qubes receive some request from a relay VM. So in that case, it's the remote relay that say, "Hey, please execute some RPC from somewhere else, another Qubes." So for example, if you chain several relays, so imagine if you think about SSH jump host, you will just jump over several hosts, and the remote Qubes OS knows that you will allow some requests from this particular relay, which is called a remote relay, anything that comes through the local cube. So what we are facing right now is that we will say on, for example, on the remote Qubes, that you will accept requests that come from this particular remote relay, but we have some issue to say we are really sure that the original VM, so the local cube that initiates the communication, is really that the one you want to be sure. So that's why we might in the future implement some end-to-end verification. For example, sharing some secret between your local cube and your remote cube to be sure that in the process in between there is nothing that could change the content or anything else.
Yeah, and this is also the potential for some more use for Anti-evil-maid to have some kind of remote assistation. If you are connecting to real Qubes OS, that is still unchanged since the last time. But
yeah,
that's way in the future.
Yes, basically, we also made several precision. I mean, the particular case of using dedicated resource or and so on is also nice. But if we take also the example of having your keys somewhere, it's easier to travel and say, okay, I'm potentially able to even unlux or even you know, if I follow the presentation of this morning, you can have some relay VM which will be properly encrypted and so on, and so you can also use your keys which are somewhere else, safe in a safe place, and even if someone is pushing you to unlock your computer and so on, you can somehow prevent him to use your key as if you would use a split GPG even locally, but at least your keys are safe in a safe place. So it's also a good case.
Yeah, and I have a few more words to say about provisioning this thing. So you've seen on the diagram there are a lot of moving parts, and there are a lot of this relay VMs, remote VMs, local VMs, etc. And to make a single connection, we need several objects to be configured. So manually, it would be a lot of manual work. We will do that during development, but that's not the nice way for the users to do. So we plan to have some provisioning tool which you will tell, okay, I want to connect this local VM with this remote VM on this host using SSH transport, and it will generate all the configuration, SSH keys, etc., and give you a package you can automatically transfer to the other host, and some random idea for the how to do that in a trustworthy way is to use something like Magic Wormhole, where you have you can transfer data over the network in an encrypted and authenticated way. So you have one host where you run this tool, it prepares all the configuration, and you on the other host you run the tool to apply this configuration. You type the code words. It's like 3 or 4 words you need to type, and it downloads the file. It's verified. It's if it matches, and then it will apply the configuration, and you have the connection established. We will, at some point, we will likely improve this to make it a bit more automatic, but this authentication step needs to happen at some point. So that's the idea from the user perspective. Make the connection one, okay, type this 4 words on the other host, so you go to the other host, type those 4 words to confirm, and if they match, then connection is established. We'll see how it goes in practice. This is this design exists only on this slide for now, so we'll see. And from the management, after you make the connection, there will be not much for now. So there is the remote cube type will have very limited set of the metadata. It will have name and what relay should be used to communicate with that, and that's probably all. Maybe a color.
Yes,
maybe, but there won't be any information about its state, whether it's running or not, is it network connected or not, what template it uses, nothing like this. All the actual configuration of the cube still stays locally. We will try to add enough API to enable starting disposable cubes on the other host, because we find this as very useful use case, but full remote management is not part of this design, at least not yet. We will see. Yeah, and the reason for having this API this limited is to not require to have Qubes OS on the other side. We want this to be compatible also with like Raspberry Pi or some cloud VM or something, or even start a disposable VM, which is actually some Spot instance or Amazon or whatever else. So we want to keep the API very limited to be able to add integration with many different types and other APIs. If we require everything to support this 40 properties, then it would be much harder to make it compatible with different things.
Yes.
Yeah, and
I can also just make something is that yes, even locally, if you define some management VM, it does a lot of QRexec, calls to retrieve property and so on. And so if we go to the way of saying, okay, my remote relay has also a lot of management permission on the remote cubes, we will have some challenge to say maybe we can manage better with the Cube Manager itself locally, the remote cubes on the remote Qubes OS. And this is why we will need probably some very nice design and user experience from our dear Marta there.
She's hiding.
So yes, we will face some challenge with network and so on. So yes, there is also, this is why I said earlier that we have already several parts inside the Qubes code to adapt and to prepare to be sure that we will probably face these problems correctly. Yeah.
Hi. When you say about end-to-end verification, does the remote cube can assert the local cube is the same, or is like on the proxy level, just the relays can communicate and the relay could lie?
Yeah, so the initial idea is to leave this trust to at the relay level. So if you have several remote cubes, we will verify if cube 1 is communicating using correct relay. So if relay B try to says, hey, VM1 is trying to communicate, but VM1 is supposed to use relay A and not relay B, it will get rejected. But the identity of the remote VM behind the relay is not not part of the initial design. It could lie. It's if you have 5 different VMs behind a single relay, that single relay can lie which of those 5 VMs it is. If in this design at this level, if you care very much about this identity, use one relay per one VM. It's less efficient, but more you will have this property. We can extend it in the future, we will see, but the initial part will not have this part.
Okay, and will it require a change in the QRexec policy?
So our current plan is to not require changes. We will see. That's the idea why we register those remote VMs objects, so you can specify them as the at the policy level, similar to local VMs. Maybe we will add some special tags to say they are from remote, or maybe something like that. But we try to keep it compatible with the current QRexec.
Okay, but basically, for now, the only change that we need for now is just adding just exposing the source. We don't expose the source inside the QRexec message. So now we add explicitly the source, but somehow it needs to be trusted.
Yeah. Yeah, so there will be a change inside QRexec implementation and the QRexec protocol, but not the policy format. That's the current plan. We'll see.
Okay, thank you very much.
Thanks so much. That's extremely exciting. I'm wondering if you can speak a little bit more to the changes inside the QRexec protocol that you're describing, specifically, do you have design thinking now around what format data will be passed by RPC between the remote and the local domains? And have you thought about, do you have design thinking on that we can learn along with?
We have some design draft there. It will change probably, but for the like on the QRexec level between the relay and the DOM0, we need, like Frederick said, one extra information what remote VM behind that relay was sending that message. So that's currently the only change in the protocol itself. The other thing is this transport protocol, which we probably will pass all the data as inside the SSH for the SSH transport, as SSH as the standard input and output, and pass the argument on the command line on the SSH call. That's the current idea. Whether it will work efficiently, we will see.
If I can ask a follow-up question. So this is relevant not just for the idea of like the remote to local connection, but also in terms of thinking about how are we going to process data between VMs on the same machine. Sometimes we've run into questions about can we pack enough data into an RPC call, or is there a need for like a more rich format that can pass more information back and forth? And so I'm wondering if that fits into this design as well.
Yeah, we know this complaint. So yeah, this is something we don't touch in this design really, because the QRexec remains as a like data pipe between start and end. There is no forced any protocol. One thing that we did extend it in 4.2, the argument to a QRexec call can be way longer now. Yeah. It's 60 something kilobytes. So we can pack a lot of data in the argument itself, but you have some limited character set to encode.
Yeah. Super exciting. Thanks so much.
For the record, we faced this problem using Windows build executor.
Yeah,
command line was too big.
Yeah, thank you really much. Also really exciting. And so the first question is kind of what's kind of the timeline here? Yeah, that's basically the first question. Okay. When this what you just showed?
The current plan is to have the base version, base scope I showed in the one of the initial slide, included in 4.3. So that's
a clever way to not answer the question.
I know I didn't set any time about that, but
well, you threatened with feature freeze at the end of this year for 4.3, so
that's not public information. Yeah. Yeah, so that's the current plan. As usual, we'll see. Historically, we try to release Qubes version every 2 years, so you have some idea.
So we don't have to wait 6 more years.
Hopefully not.
Nice. Good to hear an update on Qubes Air after quite a while. So if basically like remote VM is derived from Qubes VM, what does this mean regarding the concepts of app VMs, disposables, templates? Will there also be remote disposable?
The current plan is no. That will be hidden. So you can have a remote VM that is a template or is app VM or something. We don't transfer this information. The remote VM is a single type which encodes some remote entity. Okay. That's the current plan. Maybe we'll extend it at some point, but we want to keep it simple, to be flexible, because the other end may not be even a Qubes system, right? It can be a Raspberry Pi with a single Linux system there. So yeah, that's the current idea. We'll see.
Makes sense. And then I also wanted to ask, so I didn't fully get the diagram. I don't remember if there is like a remote policy thing. Okay, yes. So the policy is decided by the remote system and not by the host.
Both, actually.
Okay, yeah. You need to consent to sending something to the other one, and then on the other one, like for example, if we have like split GPG, the other one is the one who decides if it allows this policy
Yes,
from this remote.
exactly. Both sides needs to agree.
Okay.
This is extension of the initial design where there was some primary instance. I should probably avoid using word master, but the primary instance and other instances are some clones. Here we have. We don't have like it's on the same level. None of those local or remote DOM0 is have more privileges of another. It's symmetrical here.
Okay, sounds good.
Yeah.
So basically,
you can have more of them. You can have cloud of cube systems.
Exactly.
So, yeah.
Yeah.
Basically,
And in this consideration, because the problem seems quite similar, maybe there is also some space for solving the problem of remote of policies for admin VMs, of like where that should be decided and how that can be decided. Because I mean, it doesn't have to be solved with this. I just think that it's a related problem.
There is one related, well, not directly related to this, but somebody come with idea of having multiple tags in a single policy rule. So that's helpful a bit. I have some more ideas, but they are not designed enough to even put on any slides. So.
Okay. Sounds good. Thanks.
Yeah, you mentioned this problem of proxy. Like, is it am I talking to real one or proxy one? So it seems that you're facing the root of trust for identity problem. Yeah. So, and your solution right now is pairing based on something that on both sides is known. Yeah.
Yes.
So, but like first of all, like a root of trust for identity, like this solution is very well discussed in Calyptra. And all this TPM DICE related things, and you mentioned anti-evil-maid, so maybe the answer will be related. Like, does it make sense to go into direction of realizing what's the state of the platform, and if the state does not reflect the real identity of the platform we're talking with? That's one question. And second question about this pairing. This is sounds very weird because how I would know at the point of establishing connection, these images or these words, whatever, will be on both sides. I don't know, I'm in other country, I want to connect, and how I will realize at this point? I cannot realize at this point.
That pairing actually is very similar to, I don't know, verifying signal fingerprint or any other fingerprint. You need some other channel to transfer these code words to the other side. If it's your friend computer, you simply can call him and
ask, okay,
type those 4 words if you trust me or something.
Yeah.
But to answer your first question, right now we established this trust on this initial setup based on magic wormhole or something similar, and then both sides have some secrets. In case of SSH, it's host key and the user key, so there is mutual authentication here, but at some point we may also extend it with some remote attestation based on DRTM, so we can also verify if the remote site is still the same, if not somebody replaced the hypervisor or something. But for that to be meaningful at all, we need some version with locked down DOM0, because it doesn't say anything about the state, what QRexec will do if you verify just the hypervisor, because DOM0 can do anything. So for that to be meaningful, we need a bit more locked down DOM0, which may or may not come in the future in some of the version of configuration. We'll see.
But about the release schedule roadmap, is there for R4.3, is there even a milestone on GitHub or something which gathers all this, so you can see?
There used to be. I'm not sure if GitHub did something funny to the GitHub project.
But maybe other way. How are you tracking that? It's in your head or somewhere?
No, there is some issue.
It's in your head.
Yeah,
that's bad.
There is physical representation.
There is very small buzz factor here.
Yes, there is physical representation. I have stickers Yeah, but I will put that on GitHub.
Okay.
Yeah. But yeah, but you can track the work done on this particular issue. This one. Yeah.
Hey, super interested in how all the authentication is going to work out on sort of setup and on these individual calls. I was reminded of the idea from earlier of UUID identities. Seems will be more useful when when you're on another machine, and I wonder if you can tie that to something like a public key for the sender that signs it. I don't know. What was more of a question was what additional challenges do you think you'll get sending RPC over a network now, so that classic problems of your transmission is lost or delayed? Does the current protocol has some timeouts and things, I assume, already to accommodate for some of that?
Yes, so the current, this will require some more work because the current protocol have some timeouts on the connection setup. So if the connection, the other connection, you cannot reach the other host, it will, I think there is 1 minute timeout, half minute, something like that. So this part is there, but if your connection dies past the, in the middle,
It will fail.
No, it will wait forever, basically. So yeah, this will need some improvement. So that's basically up to this transport service. SSH will time out eventually. Sure. If we use, I don't know, TCP over WireGuard, this will also time out eventually if it doesn't work. So it's up to the transport service. But yes, those timeouts may be long and may be inconvenient. So we'll see how it works in practice.
Yeah, fun problems.
Yes.
So you mean we will have some transport that will manage retry?
We'll see. It's not there are problems there, but we'll see.
Yeah, I wonder if those are questions from Demi about could CAP and Proto RPC be used? I guess, is it related to that? Is it sounds like related?
Current ideas are about using existing, for example, SSH transport and not encoding extra data. We have that protocol, QRX protocol already. We don't need anything new there. We specifically make it that the transport services, we can use different transport services for different relays, different remote cubes. So yeah, if somebody wants to write something new,
yeah, contribution welcome.
Yeah, we have specifically, we are not hard coding. It must be SSH or something. It's flexible that you can choose different options. You can use, I don't know,
Android attestation, like Demi suggests also Android attestation.
Yeah, if you connect to something, maybe. So there are some ideas. We'd like to keep the initial plan, initial design simple and flexible enough that we can actually deliver something in time, and also we can also extend it for some other use cases later. Okay. So, I guess.
Okay, so just couple last words for today. We're finishing shortly because of this cancelled presentation, and we had hoped that discussion with Marek and Frederick will be longer, but it's not. So I guess like we can finish earlier. So let me close the first day. So one more time, we have to do this. Congratulations to Freedom of Press Foundation for supporting the event. And of course Malvat for providing wonderful VPN and supporting the event. And of course we're meeting here at 7:30 p.m. Of course I think there will be people which will go there directly. So yeah, if you will be there earlier, just like reserve seats, and I guess like we will gather like usual, like every year. And I guess that's it. Tomorrow morning we start at 10 a.m. So be careful how much you're drinking, because you may be missing first talk or maybe a couple first talks. So yeah, but anyway, maybe you don't have to sleep, then that's fine. Yeah, so see you in Sudblock today evening. Thanks.